Hello.
Good afternoon.
Good afternoon, sir.
Hello. Good
Hello.
afternoon.
Good afternoon, sir.
Good afternoon. Hello, madam. How are you?
Sir, I'm very fine. तुम्ही कसे आहात?
ठीक. Okay. So,
I was waiting for the link, but at last I dropped message to you.
hello, madam.
I'm
Jyoti,
sorry
madam.
for that dropping the message.
Hello, Jyoti, madam.
Sir.
Yes, sir. Good afternoon.
Good afternoon. After a long time,
Yes. We we
we are meeting here online.
Yes, sure, sir. अभी सर स्टार्ट अभी टाइम लगेगा या हो गया?
Yes, 3 o'clock. At 3 o'clock, we will start. There are time now. 12-13 minutes are there. Okay.
Okay, sir.
Hello. Good
Hi,
afternoon,
good
lady,
afternoon.
madam.
Yes, good afternoon. Thank you for the invitation.
Okay. Now you are always accepting our invitation. Yeah.
We just finished this morning, so that's our background, the one I'm using right now.
Oh, yeah, yeah.
We already finished our session.
Okay.
Hello, good afternoon to all. Good morning, sir.
Hello, madam. Good afternoon.
Yes. How are you, sir?
Fine. And where is the sir? Sir has joined or not?
No, sir, he is traveling. He was out of station.
Okay,
He's
out of
traveling.
station. Okay.
So we have some time, no? 10
Yeah,
minutes?
3 o'clock we start. Yeah.
Yeah, sure.
Hello, good afternoon, sir. Gurunle, sir.
And good afternoon.
Is it okay if I try my slides just to see?
You can, yes, you can try. Yeah.
Okay, thank you.
Randale sir.
Let's see.
Randale sir, allow.
Yes, sir. Yes, sir.
Share the screen.
Sorry.
Lady madam trying.
Okay.
Yeah,
Whether
hold on.
slides are sharing or not. Okay.
Let me just see. Yeah, I can share.
She will share her presentation.
Yes. Okay, madam. Yeah.
Can you see it?
Yes, madam.
Yes,
You
madam.
can change. Yes.
Okay, hold on. I have a problem. I cannot see mine. Wait.
No, but screen is visible.
Yes, hold on, okay?
First slide is visible. Okay.
Let me see, hold on. Let me close. I cannot. Okay, and then, hold on. I want to do presentation mode. I don't know why. Can I just stop share?
Okay. Yeah.
Okay, I don't know. Okay. Oh, maybe here. That's why. Then now see my screen and I want to. Hold on, because I'm using Canva and I'm trying to figure it out.
Okay.
Okay. There you go. Maybe I should do this. So present. Okay. Can you see?
Yes, yes.
And this one, can you see the, is it moving?
Yes, moving. Yeah. Yeah, yeah.
Okay. And then it's just one slide. Just just the, you don't see my,
This is first one.
okay, good.
Take next. Yeah, next.
Okay. All right.
Yes, yes.
Okay. Thank you.
It's changing. Moving. Slides are moving.
Okay. Thank you.
Okay, yeah, yeah.
I'll stop.
I'm waiting for the Sonia madam. Hello, Lanjay sir.
हा बोला सर. हॅलो 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 आवाज येत आहे सर.
हो हो हो, एक मिनिट सहाशी बोलत आहे. हो हो. त्याला काय करायचं आहे? राईट क्लिक. हा हा, एक मिनिट. पराग, इथं होस्ट बनवायचे. मला होस्ट बनवायला पण इथे रंजीत सर अभी प्रभु सर ज्वाइन होने के हैं सर। हेलो
हाँ हेलो सर,
हेलो
आवाज जा रहा है?
हेलो हेलो विजय हेलो विजय रंगल सर
Yes, sir. Yes, sir.
हेलो
हाँ sir, you're audible.
हाँ तुझा आवाज थोडा मोठा कर increase the volume
Okay, sir.
रंजीत सर we are waiting for Prabhu sir and Pare sir.
Okay sir, okay.
And also our one speaker has still not joined, Sonia. Okay. Hello. Hello, Professor Sonia.
Hello.
Hello. Good afternoon.
Good morning.
Okay, you are having morning, but here we are having afternoon.
Yes, there is good afternoon.
Thank you
Wait,
for
I'll turn on the
joining.
light.
Thank you. Thank you.
Yes. It's raining here, so it is
Oh,
a bit dark.
okay. How is the college going on? You are teaching.
Not yet. It's interval between the classes of the first and second semester.
Okay.
Classes start next month.
Okay. This is good time, na?
Yes, it is a very good time now. Yes, indeed.
That's why you are ready. You are here.
Yes.
Yes,
True,
yes. Thank
true.
you for accepting.
Oh, thank you for the invitation.
Yeah. You are also not coming for the international conference. Professor Singh is taking. Professor Ajay Kumar Singh.
Oh, nice.
Yeah. On 14th and 15th this month.
Oh, 14 and 15. Okay.
I think you received the invitation.
Oh, nice.
Yeah.
That would be nice. Yes.
Sir, good afternoon, Prabhu sir.
Good afternoon. Good afternoon.
Professor Prabhu sir, Professor Sonia from Portugal has joined.
Oh,
Professor Anjali Rajbhog madam also joined.
okay.
And Professor Glady from the Philippines University.
Okay.
Also not
Grand
visible.
welcome. Grand welcome to all the professors.
Good afternoon.
Hello. Hello.
Thank you.
Hello. Hello.
Thank you,
sir.
sir. Thank you.
Hello
Thank
to
you.
all of you, madam. Hello, speakers. Professor
Yes, thank
Prabhu sir is the president of Association of Chemistry Teacher.
Yes, sir. Yes, sir. Nice to meet you.
Now, yeah.
Nice to meet you. Yeah.
Prabhu.
Rahandale, sir. My voice is clear.
Yes, yes.
Yeah.
Audible.
Okay.
Prabhu sir, Pare sir is not still not joined.
Acha, acha. He will join you.
Oh,
Yeah.
डॉक्टर डी प्रभू
कुठे आहे ते? लिहून द्या. नाही. इथे नाही ना ते. बरं जा, मी तुला फोन करते. ठीक आहे. बेल नाही वाजत आहे. फोन कर मी.
Prabhu sir, now Paris is joining just now.
आपल्याला नवीन नाही दिसलं त्याच्यामुळे
Hello Vijay, you are ready now?
Yes, sir, I'm ready.
Okay. Hello, Professor Paris sir.
हॅलो
Hello sir.
सर परे सर जॉईन नाही झाले का?
झाले. Hello,
झाले
Professor
ना?
Paris sir. Good afternoon. Hello.
हॅलो
Paris sir, good afternoon. Hello, Paris sir, good afternoon. Hello, Paris sir, unmute yourself. Hello, Paris sir. Hello, Paris sir, good afternoon.
Good afternoon, sir. Good afternoon.
Yeah. Vijay, we can
Sir.
start now. Yeah.
Shall we start? Okay.
Yes.
I request all the participants, please kindly mute your mic. Yeah, then we can.
बाकी सगळं रेडी आहे उद्या झालेला आहे
Dear participants, please mute your mic.
Hello, Vijay, start now.
Okay, sir. So, respected delegates, eminent speakers, and dear participants from country and abroad, a very good afternoon to one and all. I feel privileged to welcome you all on behalf of organizing committee for today's international webinar on accelerating equity in science, organized by IQAC and Department of Jagat Arts, Commerce, and Indiraben Hariharbhai Patel Science College, Goregaon, District Gondia, India. Society for Promotion of Material Science, Nagpur, and Association of Chemistry Teachers, that is ACT, in collaboration with IUPAC Global Women Breakfast. Let's have some brief idea about what is GWB, that is Global Women Breakfast. So the Global Breakfast is an event that happens once a single day in February of each year, with the aim to celebrate the accomplishment of women in science and to inspire younger generations to pursue career in science. Women and men from all types of science organizations come together to share breakfast either virtually or in person. A central goal is also to establish an active network of both men and women to overcome the barriers to gender equality in science. The Global Breakfast facilitates the formation of communities on a local, regional, and international scale to effectively share ideas and strategies for progress. To fulfill the above mentioned objective, this one-day international webinar on accelerating equity in science is organized today on a virtual platform. So, moving further, I would introduce and welcome Honorable Sri Jagatramji Rahangdale, President of Bahujan Hitai Jagat Shikshan Sanstha, Gondia. Although he could not join for today's webinar, but his blessings are always with us. Now I welcome Chairperson and President of Association of Chemistry Teachers, that is ACT, Honorable Professor D.V. Prabhu. I also welcome our Chief Guest and ex-President of ACT, Professor Brijesh Paresar, for being with us. I welcome Vice President of ACT and convener of today's webinar, Dr. W.B. Gurdule sir, Professor and Head Department of Chemistry, Kamala Nehru Mahavidyalaya, Nagpur. He is also a Secretary of Society for Promotion of Material Science, Nagpur, and he is Vice President of ACT West Zone. I also welcome Dr. N.Y. Lanje sir, Principal, Jagat College, Goregaon. So, I think maximum participants are now joined. So let us move to the inaugural session of this function. I invite convener of this webinar, Professor Gurnule sir, to give welcome address. So please over to you, sir. Gurnule sir, please unmute your mic.
Good afternoon to all of you. On behalf of ACT and organizing committee, I welcome all the resource persons, academicians, and participants for this IUPAC International Webinar on Accelerating Equity in the Science, which is organized by IQAC and Department of Chemistry, Jagat Arts, Commerce, and IHP Science College, Goregaon, and the Society for Promotion of Material Science, Nagpur, in collaboration with Association of Chemistry Teachers, Mumbai. And this is the Global Women Breakfast 2025. For this webinar, Honorable Professor D.V. Prabhu sir, President of today's inauguration session and President of Association of Chemistry Teachers, Mumbai, Honorable Professor Brijesh Parekh sir, ex-President of ACT and Chief Guest of today's inauguration function of this webinar, Dr. N.Y. Lanje sir, Principal of the Jagat College, Goregaon, and dear participants from the globe and from the different part of the country. I extend warm welcome to Professor Brijesh Paresar, ex-president of Association of Chemistry Teachers, Mumbai, for accepting our request to be chief guest for this IUPAC GWB 2025 and international webinar. I also welcome Professor D.V. Prabhu sir, president of ACT, and sir has kind enough to have spared a valuable time and to be present here. We are highly obliged to you, sir. I offer a warm welcome on behalf of organizing committee. For the inauguration, Professor Dr. N.Y. Lange, sir, Principal of Jagat College, Goregaon, is present here. I also welcome and Dr. Sanjeev Kumar Angdale, co-convener of this webinar, are present here for this IUPAC International Webinar GWB 2025. As we know, chemistry is the central science having useful link with all other sciences and especially the biology, physics, chemical biology, biophysics, bioinorganic chemistry, which has made a tremendous progress in the last few years. In the last few years, some novel material, that is multifunctional materials, have been developed with interesting properties like nanomaterials, superconductors, and multifunctional materials. And there are many societies of chemistry education which have made tremendous contribution to the science and technology. The backbone for sustainable development is the science and technology. Science and technology are different, but at the same time, they are complementary with each other. Material are size dependent, and material are solids, which can be tailored to develop desired properties applied for the fabrication of devices for the benefit of the society, and properties are because of being solids. Material science, engineering, innovations will have an important role as a resources to address sustainable development, and which is the need, and perhaps nanomaterial may play a very important role. So main objective of organization of this international webinar is to provide a platform for interaction and collaboration among eminent professionals, researchers, scholars of different field, and to discuss the share of art development in the accelerating equity in the science. This webinar will be definitely beneficial to the participants in their field in general. As we know, IUPAC serves the international scientific endeavor in the dual function of basic science and mission-oriented union. The event is a unique position central interdisciplinary chemical sciences, strengthening the international chemistry, striving towards the inspiring high standard of excellence and relevance in academic and industrial research, and promoting the services of chemistry to the society and to the global issues. These are the visions that shape IUPAC activities over the 21st century. 2025 IUPAC Global Women Breakfast event. This event will be held on a single day, that is on 11 February 2025. And the theme of this GWB 2025 is accelerating equity in the science. As we know, GWB Global Women Breakfast was started from 2019 onwards by IUPAC. The main aim of the GWB is to demonstrate the need to build a network of both women and men working together to address the barriers and inequalities faced by women in the science. IUPAC is a unique position to serve as a leading organization and global platform where these difficulty and persistent issues can be addressed in a transparent manner. For this international webinar, around 2,500, more than 2,500 participants have registered from different countries like France, Indonesia, Bangladesh, Nigeria, Malaysia, Nepal, Oman, Canada, Philippines, Morocco, Afghanistan, Hong Kong, and almost all the state of India. So I welcome you all, the participant on this occasion. We have the opportunity to be benefited by the keynote talks of Professor Sonia Carabiro from Nova University of Lisbon, Portugal, Professor Gladys Complesto, Professor of Chemistry, Institute of Chemistry, University of the Philippines, Los Bonos, Laguna, Philippines. Professor Anjali Rajbhoj, Senior Professor of Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar, India. So at last again, as the convener of this international webinar, I welcome all the research persons, speakers, academicians, and all the dear participants. Thank you. Over to you, sir.
Okay, thank you, sir. Sir has explained all the objective and goal of this GWD and today's webinar. Thank you very much, sir. Now I invite Dr. N.Y. Lanje, sir, Principal, Jagat College, Goregaon, to share his introductory speech. Please, sir.
Sir, I am audible.
Yes, yes.
Good afternoon to all of you. Respected President of our Society, Baujan Hitai Jagat Shikshan Sanstha Goondiya, Honorable Sri Jagat Ramji Rangale, Secretary Honorable Sri Narayan Jade, President of Association of Chemistry Teacher Mumbai, and today's webinar President Honorable Professor D.V. Sir, Chief Guest Professor Brijesh Paresar, ex-President of ACT, Vice Principal of our college, Dr. S.S. Bhairam sir, Vice President of SPD and convener of today's IPAC WD 225 webinar, Dr. Vasudev Gurgu sir, today's eminent speaker, Professor Sonia Carbineiro, New University of Lisbon, Portugal, Professor Gladys Completo, Institute of Chemistry, University of Philippines, Professor Anjali Rajbhog, Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar, Maharashtra, India, Dr. S. Dr. G.K. Bhagat, Professor Jadhav, as well as Dr. S.S. Rangale, Department of Chemistry and IPC Coordinator of our college, co-convener of today's webinar and anchor of today's program, Dr. Vijay Rangale, member associated with ACT, IUPAC, Global Breakfast, all the teaching and non-teaching staff of our college, and all the delegates who have joined this webinar. I like to take this golden opportunity to exercise my humble privilege as a principal of the college at this auspicious day, International Day of Women and Girls in Science, 11th February 2025, the day of international webinar on accelerating equity in science, organized by Society of Promotion of Material Science Nagpur, Association of Chemistry Teachers, IQAC and Department of Chemistry of our college in collaboration with IQAC Global Women Breakfast to welcome all the scientists, eminent research scholars, delegate invitees, friends who joined to participate in this webinar from other countries as well as different part of our great country India emerging to the world of peace and progress. It is an effort of Dr. W.J. Gurdule, Dr. Prabhu, Dr. Brijesh Paresar of ACT and all members of IUPAC and Global Women Breakfast as well as S.S. Rangale sir and Dr. Vijay Rangale sir and other staff of our college as a team towards the way of great success together with the support and cooperation received from all of you. We had organized UGC sponsored national conference in different subjects and online national webinar. But this is the fourth online webinar organized by our college in association with ACT, IUPAC and WG. This webinar is an important milestone in the march of our college toward academic excellence. I am very happy to receive tremendous response from different states of India and abroad. I am delighted to inform you that growth of Jagat Art Commerce and Hariyar Patel Science College, Goregaon had his humble beginning in art, Commerce and Science faculty at the time in the year 1992 at Goregaon, a socially and economically backward place in Gondia district. Today, the college runs UG and PG courses with YCMU Center and identifies itself as one of the premier educational institutions of Rashtrasant Tukadoji Maharaj Nagpur University, Nagpur. Our college re-accredited C+ grade by NAC Bangalore. Our college is run by Bahujan Hitai Jagat Shikshan Sanstha Gondia, a pioneering citizen society in Gondia and Gandhara district, and established in the year 1991 by great visionary and philanthropist Honorable Sri Jagatram Rangdale, with pious purpose of leading the socially and economically backward section of the society to the light of learning and knowledge. In 2015, the United General Assembly declared 11 February as the International Day of Women and Girls in Science. On today, 11 February, we organize international webinar on theme Accelerating Equity in Science, is arising to provide a platform for interaction among eminent scientists, professors, researchers, and scholars in the field of chemistry, physics, and other science subjects. We hope to inspire and motivate the next generation of scientists. The Global Women Breakfast is an international initiative promoted by IUPAC. Of the International Year of Quantum Science and Technology. WGB is a global event taking place simultaneously worldwide, aimed at promoting an active network to highlight and overcome gender inequity barrier in the science. The aim of this webinar, Accelerating Equity in Science, is to motivate and encourage females in the field of science. One of the breaking barriers in science is the lack of gender equity in science. It is not just a problem that affects women, but also impact a country development. Moreover, when we limit the size of talent pool by making it harder for girls and women to choose a career in science, we compromise our capacity to solve complex problems. While women represent only about 1/3 of the world's research scientists today, that number is sure to increase dramatically if the number of women graduating with degrees in science will increase. Evaluating diversity leads to scientific excellence. The progress of science, and most importantly, it is simply the right thing to do. We must value diversity not only in words but also in action. Professor Sonia will deliver the lecture on the topic Accelerating Equity in Catalyst, Gold versus Noble Metal Free Catalyst. Professor Gladys Templeto will deliver her lecture on the topic Accelerating Equity in Nutritional Health, the role of functional food in combating malnutrition. And Professor Anjali Rajput will deliver her lecture on the topic Impact of Nanotechnology in the Modern World. I express my gratitude to Honorable Sri Jagatramji Rangdale, President, Honorable Eminent Secretary of Bhojari Parishad Sanstha Gondia, and Dr. W.B. Gurmile sir for their constant support for this activity. I extend my wishes to one and all associated with this conference. Thank you very much, sir. Over to you, Rangdale.
Thank you very much, sir, for sharing your thoughts through the introductory speech. Now I invite our chief guest and inaugurator for today's webinar, Professor Brijesh Pare sir, to deliver the inaugural speech. Before going through his inaugural speech, I would briefly introduce him. Sir has vast teaching experience of 33 years on UG and PG level. He was postdoctoral research fellow in the Department of Chemistry, University of Durban in the year 2000.
I'm audible?
Yes, sir.
Okay, thank you so much. So I take this opportunity to congratulate the organizers of Global Women Breakfast 2025 at your center. And see, this program is really getting popular. I remember, like when it was started, very small number of institutes and colleges and universities were participating. But now this year particularly, India is leading in that. Almost, I think it is taking place in 100 countries. And being Indian, I'm really proud of it, and particularly the Association of Chemistry Teachers. We are just what I should say. We are leading this program, across India, and more than 80 colleges and universities they are taking part in this program. So really, it's a great, and I really congratulate Professor Gurunale and the principal of this college for having taken this opportunity to organize an international event where many speakers from outside are taking part. And the aim of this program, that is Global Women Breakfast, is to have a network of women scientists, teachers, and just to have a network, to have a connect, and at the same time to encourage the young students of the college and universities. So I'm very much hopeful that this program definitely going to aid a large amount in terms of academics to your institute. And please keep on doing it. And once again, I congratulate the principal and the Gurunali sir for this program. And thank you for giving me this opportunity to join you people. Thank you so much. And I hope Professor Prabhu is there, and will just let you know that how Association of Chemistry Teachers is spearheading this program in India. And more than 80 institutes are doing this. So once again, congratulations. Thank you so much. Thank you.
Thank you very much, sir. I will add a little thing. Sir has ex-president, is the ex-president of ACT and currently serving as a professor and head Department of Chemistry in Government Madhav Science PG College, Ujjain. So thank you very much, sir, for being with us. Now, I invite Professor D.V. Prabhu, sir, President of ACT, to deliver the presidential address. But before listening his speech, I will briefly introduce and I will go through his biodata. Dr. D.V. Prabhu is an adjunct professor and former head Department of Chemistry, Wilson College, Mumbai. At present, he is the chairman of Bombay Association for Science Education, that is BASE, which organizes several science activities for school and junior college teachers in India and abroad. He has guided 8 students for their research degree and published more than 100 papers to date in very reputed national and international journal. And he has delivered 80 presentations in national and international conferences in many countries. Here I will add, sir is a recipient of many awards, including FRSC, elected fellow of Royal Society of Chemistry, London, in May 2019. Sir has also awarded by Best Chemistry Teacher Award of Chemical Research Society of India in 2006. So thank you so much, sir. So please, sir, I invite you to express the views about this webinar. Thank you, sir. Professor Prabhu, sir. Sir, please unmute your mic, sir.
वगैरह
Professor Prabhu, sir, am I audible? Please unmute your mic, sir, so can we hear you.
Who can unmute also? Rangaji sir, unmute
Sir?
Professor Prabhu.
Okay.
Rangaji sir.
Yes, sir. Yes, sir. I'm doing that.
Can you hear me?
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir.
Okay. Thank you for the kind introduction. Principal Lanje, Principal of Jagat College of Arts, Commerce and Science, Professor Vasudev Gurnule, the ACT Vice President and the convener of Global Women's Breakfast, Professor Brijesh Pare, the former president of ACT, the faculty of the Jagat College, student friends, and all the other participants. It's a great pleasure for me to be associated with the IUPAC Global Women's Breakfast, which is organized by your institution. The Global Women's Breakfast is an annual function of IUPAC, and it is held on a particular day in February. And the goal of this international event is to overcome the barriers to gender inequality in science. The theme of the Global Women's Breakfast 2025 is Accelerating Equality in Science, and the event has been organized in support of the International Year of Quantum Science and Technology. The Association of Chemistry Teachers of India coordinates and supports this activity in India and motivates colleges, universities, schools, and scientific institutions to organize chemistry programs to celebrate Global Women's Breakfast. Over the last 6 years, since 2019, more than 2,000 breakfasts have been organized in over 100 countries. The Global Women's Breakfast is in keeping with the 17 UN Goals of Sustainable Development, particularly the goal of gender equality, wherein women and men get equal chance to participate in science and reducing gender inequality. In most of the developing countries, there is still inequality between men and women as far as science is concerned. And this Global Women's Breakfast seeks to bring down the barriers so that women can participate equally as men. This year, as Professor Pare said, we are having a record number of 86 entries from all over India. And this is roughly 20% of the total entries worldwide. So in 86 institutions today, we are celebrating chemistry and we are celebrating the achievements of women in science. I would like to particularly thank all the organizations, the teachers, the students, and the scientists who have taken care to organize this breakfast. Special thanks go to the national coordinator, Professor Vijendra Singh, for taking so much pains to bring together 86 institutions to have Global Women's Breakfast. Association of Chemistry Teachers is the national organization of chemistry educators. It was started way back in 2000, thanks to the initiative taken by Homi Bhabha Center for Science Education, TIFR, Mumbai. Through its various activities, the association brings together school teachers, college teachers, university teachers, scientists, and policy planners to chalk out programs related to chemistry. Some of our programs are conferences, training workshops, research convention. Then we have a newsletter edited by Dr. Vasudev Gurnule. Then we have a website, concept test in chemistry for BSc students, and collaboration with international organizations like IUPAC, Royal Society of Chemistry, American Chemical Society, to organize activities which are useful to our teachers and our students. Every year we honor the outstanding teachers of the country by giving awards, including a Lifetime Achievement Award. We have a large network of active members, then institutional members, and we have some honorary members who are all very distinguished scientists and academicians. Professor C.N.R. Rao Bharat Ratna is the patron of our organization, and we also have with us Professor M.M. Sharma, then Professor G.D. Yadav, then we have Professor John Warner, the father of green chemistry, as our honorary member. I would urge all the teachers in the group to become life members of our association and participate in our activities. I would like to congratulate the staff of Jagat College for organizing this Global Women's Breakfast, and I wish the event grand success. Thank you for inviting me.
Thank you very much, Professor. Now I invite organizer of today's webinar, Dr. S.S. Rahangdale, Associate Professor in Chemistry and IQAC Coordinator, Jagat College, Goregaon, to propose the vote of thanks for this inaugural function. Please, sir, over to you.
Am I audible, sir?
Yes, sir.
Good afternoon to one and all. IUPAC International Webinar on Accelerating Equity in Science, UWB 2025, organized by IQAC and Department of Chemistry, Jagat Art, Commerce and Science College, Goregaon, Society for Promotion of Material Science and Association of Chemistry Teachers, ACT, Mumbai, in collaboration with International Union of Pure and Applied Chemistry, Global Women's Breakfast 2025. First of all, I would like to vote of thanks Honorable Sri Jagatramji Rahangdale, President, Honorable Sri Narayan Rauji Yede, Secretary, Pujan Hitai Jagat Shiksha Sanstha Gondia, Honorable Professor Dr. S.S. Bairam Sir, Vice Principal Jagat College Goregaon. They always have been a source of inspiration for us, though they could not join, but their blessings are with us. I am thankful to Honorable Professor Dr. D.V. Prabhu Sir, President ACT, Wilson College Mumbai, who shared his valuable thoughts with us in his presidency. I express my sincere thanks to the inaugurator, Honorable Professor Dr. Sir, ex-President ACT, Madhav Science Postgraduates College Ujjain, who guided us. Thank you very much, sir, for the knowledgeable and informative talk. I am also thankful to Honorable Professor Dr. W.B. Gurnule, sir, convener of International Webinar, for the welcome address. I would like to thanks to our principal, Honorable Professor Dr. N.Y. Lanje, sir, Jagat Art, Commerce and IHU Science College, Goregaon, for his introductory remarks on today's webinar. I am personally and on behalf of organizing committee thankful to the resource person, Honorable Professor Sonia A.C. Calvinero, New University of Lisbon, Portugal. Honorable Professor Gladys Completo, Institute of Chemistry, University of Philippines, Los Buenos, Laguna, Philippines. Honorable Dr. Anjali S. Rajboj, Senior Professor, Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Sambhajinagar. I am also thankful to the entire participant from various states of India and also from different countries like Bangladesh, Indonesia, Nigeria, Portugal, Malaysia, UAE, Oman, South Korea, Canada, Hong Kong, Zimbabwe, like these countries for giving warm response of international webinar. All the staff members of Organizing Institute also need to thanks because they did not leave undone to make the conference a grand success. At last, I give thanks all those who help us directly or indirectly to make this international webinar a grand success. Once again, I express my hearty thanks to men and all Thank you very much.
Thank you very much, sir. Now, once again, I welcome all the delegates and participants joined here for this one-day international webinar on accelerating equity in science. Now, it's the time to start the technical session for which we are eagerly waiting. A small request for all the participants is that their queries may be discussed after each technical session, or they may put their questions in the chat box so we can discuss it. So we have very eminent and distinguished speaker from different countries to deliver their talks. Before inviting our first keynote speaker, Professor Sonia Carbeneiro from Nova University of Lisbon, Portugal, I would briefly introduce her. So Sonia Carbeneiro, ma'am, graduated in applied chemistry at the Nova University of Lisbon, Portugal, and obtained her PhD degree in chemical engineering in 2001 at the same university. She was a postdoctoral researcher from 2001 to 2003 at Leiden University, Netherlands, and from 2004 to 7 at the University of Lisbon, Portugal. From 2007 to 2013, she was assistant researcher at the University of Porto, Portugal, and principal researcher from 2013 to 2018. In 2019, she was invited a visiting professor in Wuhan Textile University, China, and integrated researcher at the University of Lisbon. She obtained habilitation in chemistry at the same university. In 2020, she became an assistant professor at the New University of Lisbon. She is a co-author of more than 25 chapters in books, more than 250 articles in international scientific journals, more than 220 communications to national and international conference, and have more than 20 invited talks in different countries in international conferences. She is a co-convener of one worldwide patent also. She is an evaluator of several international project proposals. She has more than 10,000 citations and H-index of 56, which is a very great value. She is a regular referee of several international journals, being currently one of the top female reviewer in the world Publons. She is also a member of the editorial and reviewer board of several journals. Her research interest deals with catalyst by gold nanoparticles, single and mixed metal oxides, nanostructure carbon materials, heterogenization of homogeneous complexes, gas and liquid phase oxidations, and environmental catalysis. So today she will deliver a talk on accelerating equity in catalyst, gold versus noble metal-free catalyst. So I welcome you, madam, and please, over to you, madam, please.
Thank you very much for the nice introduction. Thank you also for the invitation to speak here today. It's a great pleasure. So please allow me to share the screen. Okay. And to start. Okay. I hope it works. Yes. Yes, so as it was said, I am going to talk about gold versus noble metal-free catalyst. So make a comparison. So give both of them the opportunity to be catalysts, to make a comparison, shall I say. Well, as it was said, I worked before in the University of Porto, which is on north of Portugal, there. And then I moved to Lisbon, which is here. And recently I'm at Nova University of Lisbon, that is at the other side of the river. So it's South Branch there in Caparica. So just for you to see a little bit of the geography of Portugal. So I'm going to present work that has been done in all of these institutions. The synthesis of nanostructure metal oxides can be done by several ways, and one of them is the decomposition of the precursor. Therefore, by calcination is one of the methods, for example. So the metal precursor, usually a nitrate, is heat treated above 500 degrees in air. Can also be some other method, like for example, precipitation. The precursor is dissolved in water and the pH of the solution is raised by addition of an hydroxide solution, for usually until a basic value 9 or 10 is common, and then is H, means we let it some time pass, some hours usually. So the solution is then filtered and the precipitate is washed, because during that aging time there is precipitation. So the precipitate is washed, is dried in an oven and calcined, usually above 500 degrees in airflow. And we have here a nice scan image of cerium oxide obtained by precipitation. There are other methods, like for example, hydrothermal or solvothermal methods, in which the precursor is dissolved into either water, if it's hydrothermal, or an organic solvent, if it's solvothermal, and is added to an hydroxide solution. So again, the basic solution. And is transferred to an autoclave, H, at the desired temperature, usually above 80 degrees, and it's stirred. And the mixture is cooled and centrifugated, then again, it precipitates, then the precipitate is washed, dried, and calcined. But metal oxides can also be obtained by other methods, like, for example, exotemplating. So the exotemplating method, in this case, I used carbon materials that are sampled with a high surface area and surface reactive oxygen are obtained. So how does this work? You see, we have here a porous template, a carbon template, and the empty spaces of this porous template, they are filled with a precursor solution. So that means we fill it like this. Therefore, then what happens? We dry it, okay? And then the precursor carbon material is removed by calcination, okay? And then what happens? A material with the structure of the pores of the template is obtained. So it's like that. So we have here a same image, and if you look closely, you can see little holes that were where the template was. So what happens here? We have an hydrogen TPR, is temperature programmed reaction in hydrogen. So it reduces the oxygen species, shall we say, and then we see here two peaks in the TPR. So this first peak is for surface oxygen reduction, and the larger peak at higher temperatures is for bulk oxygen reduction. And these are the results for the commercial ceria sample, okay? So if we compare these results of the commercial ceria with the exotemplated ceria, see, it has a lot more surface oxygen. So because this method allows it to have, and also a higher surface area. So you see here the ST area, if we compare the commercial ceria, it is 20 square meters per gram. This one a bit better. The exotemplated, see, it has higher ones, but if you compare the hydrothermal and solvothermal, has even higher areas. So that depends on what we want to do. Also, we can compare the crystallite sizes here, and that's interesting. Here we have a temperature program distortion of the hydrogen adsorbed. So here, if we compare the commercial ceria, so almost no oxygen dissolved, you see here. And if we compare the solvothermal series, you see it has a much higher peak of oxygen. So the difference between these samples, which make them more reactive, as we will see. So we have here some 10 images of the solvothermal series, of the exotemplated series, commercial and hydrothermal series, just to compare. So we used several reactions to compare these samples. One of them was CO oxidation. It's a simple and intensively studied reaction, but still not fully understood. It's more used for gold catalysts, as we will see later, but also for this kind of material. And it has an outstanding importance in pollution control, air purification devices, indoor gas masks, cleaning of automotive gases, fuel cells, gas sensors, etc. And if we compare here the CO oxidation for all the samples, so here we have CO conversion versus temperature. So we have here the commercial series. If we compare the calcined series, we see it's better because it achieves full conversion at lower temperature. If we compare the precipitated series, even better. If we compare the solvothermal series at pH 9, we know it's better. But if we increase this temperature, what happens? It's a little worse. If we increase the pH, it's much worse. See, not good to increase this pH. And here, if we increase the temperature, also a bit worse. So the best value is this one, 120 pH 9, okay, solvothermal. Here, it's the exotemplated, but with activated carbon. And what happens is that activated carbon has ashes that decrease the catalytic activity. Because if we use activated carbon oxidized as the template, you see, it's better. However, if we use carbon gel, okay, see, it's there. It's the green one. It's better than the other. And if we use oxidized gel, not much different. So here, the best one was the solvothermal one. This is to compare the different series obtained by this method. So we have here series nanoparticles prepared by an hydrothermal method. And according to the conditions used for the preparation of the materials, we obtain either nanorods, we see them here, or nanopolyeder, or nanocubes. So the nanorods were obtained with these conditions, so 2.75 moles of sodium hydroxide, 24 hours, 90 degrees, calcined in there at 500 degrees. Okay, and if we use 0.42 moles sodium hydroxide, we obtain this nanopolyeder. If we increase the temperature, we obtain here, and this concentration is the same as in the nanorods, we obtain the nanocubes. Okay, so that is different. And here we see if we impregnate it with iron nitrate, okay, then you obtain iron on this support. So we obtain iron on cerium oxide. And if we compare these materials for CO oxidation, okay, if we compare these materials for CO oxidation, the activity order is nanorod is better than nanopolyeder, and cerium oxide is nanocubes are the worst. Okay, and incorporation of iron improves the catalytic performance, but this order is maintained. So here we have a comparison of iron oxide prepared by decomposition, and then decomposition of the precursor, and then added to cerium oxide nanorods, just to compare. And we see that the other, this is just a mixture to compare. And we see that the sample prepared by impregnation is much better here. It achieves a higher CO conversion at lower temperature. And we see that these samples, iron, when we add iron, of course, they are more active than the iron oxide itself. Here we have a good correlation between the catalytic activity, it's T50, means the temperature at 50% conversion, okay, half conversion temperature, and the abundance of oxygen species obtained by TPR, okay? And we have here both for ceria materials and for iron ceria material, okay? And we see that it's an interesting correlation. We have here also ceria nanoparticles prepared via hydrothermal method. So the same ceria nanoparticles, but this time they were impregnated with copper nitrate. So we have copper on ceria nanoparticles. Okay, so we have here the activity. Nanorods are better than nanopolyeder than nanocubes, so very similar. The incorporation of copper improves the performance as expected, and copper ceria are more active than the ceria iron material. Okay, so that's interesting to know. And also we obtain a good correlation between the catalytic activity, the T50 temperature, and the amount of oxygen species here, both for the materials with and without copper, as we had obtained for the materials with iron. I don't know why some lines appeared here in my presentation. I'm just going to stop and start again so to see if those strange lines disappear. I don't know what was it. Okay, I'm sorry. It was strange. I think somebody drew it accidentally. Okay, so we were here. Yes, with the copper. Okay, yes, we were here with the copper. Okay, and we also did Raman characterization, and it's interesting because we have these results, and this band here, F2G, it's a band that is characteristic of cubic ceria. Okay, so this is the band of cubic ceria, which is the structure that we have for ceria. And this band here, at the D band, is characteristic of defects. Okay, which is the relaxation of symmetry due to structural perturbations of the ceria cubic lattice. Okay, so what we have here is the ratio between the intensity of this D band and this F2G band, okay, which reflects the abundance of defects and oxygen vacancies. So we see here this correlation, okay. So we obtained a good correlation between the catalytic activity at T50 and the relative abundance of defects, which is this ratio, the ratio of these two bands. So quite interesting, both for the samples with and without copper. And we also obtained a good relationship, see here, between the catalytic activity at T50 and the relative abundance of copper plus species obtained from XPS results. Okay, so we suggest that the Mars van Crevelen type of mechanism is taking place, which involves the absorption of CO on copper plus species and O2 activation on oxygen vacancies, while the copper ceria interactions can facilitate the regeneration of active sites. Well, these were the results of the materials without noble metals, in this case without gold. I work a lot with gold. So we prepared some gold nanoparticles on oxide support and by several methods. So by impregnation, the support is impregnated with the solution of the metal salt, okay, following by aging, filtering, drying, and calcination. Just that Impregnation is good for platinum group metals like platinum, palladium, and so on, but it's not suitable for gold because it gives too large inactive gold nanoparticles. We have here an example: gold on cerium oxide, and the nanoparticles. This is gold, the darker one. The nanoparticles are huge. This is huge, 60 nanometers. This is completely inactive. And see, the platinum nanoparticles, by the same method, they are small. So it's quite good. The reason is that chloride causes sinterization of gold nanoparticles. They form aggregates, get together, and so become inactive. So we have to use other methods to prepare gold catalysts. So some efficient gold loading methods are deposition precipitation, for example, in which the pH of the gold precursor solution is raised until 9 or 10, depends, but 9 is usually good, with sodium hydroxide or urea before the addition of the oxide support. There is also the liquid phase reductive deposition, for example, in which the gold precursor is mixed with a solution of sodium hydroxide, aged for 24 hours in the dark, and then it's impregnated in the support. So there can be other methods, like, for example, the double impregnation method, in which the gold precursor is impregnated into the support, and then there is a further second step of impregnation with a solution of sodium carbonate. So we have here an example of gold on zinc oxide prepared by this DIM method, in which we obtain small nanoparticles. So the reason to use sodium hydroxide and sodium carbonate and so on is to do the sodium does a reaction with the chloride, forms sodium chloride that is removed by washing. Okay, so we get rid of the chloride in the materials that causes the sinterization. That is the idea. So here we have some results of gold on commercial series that we obtain very, very small nanoparticles, 2 to 5 nanometers, very good. The sizes were larger on gold on solvothermal ceria. If you remember, solvothermal ceria was the best support. And on exotemplated ceria, the particles were a bit intermediate size. So if we compare here the TPR, the temperature programmed reduction, okay, here for the exotemplated ceria, as I had said before, this is the bulk. The bulk oxygen is at a reduction at higher temperatures. In about around 500 is the surface oxygen reduction. So if we add gold to the sample, what happens? The bulk oxygen peak remains the same, but the peak of the surface oxygen is shifted to lower temperatures, which means that the surface oxygen is reduced more easily at lower temperatures. Okay, so this means that this sample can be more active, and we will see that indeed that was the case. But that's what means, as we saw, the activity is related with the oxygen, with the reducibility of the surface oxygen. So gold catalysts have advantages for the oxidation of CO because they have improved activity at low temperatures and stability in the presence of water. So the CO oxidation on platinum, for example, on the platinum group metals, follows the Langmuir-Richelieu model, which is very simple. CO absorbs, oxygen dissociatively absorbs, they get together and release CO2. Very easy. Okay, on gold, this doesn't happen because absorption is not very good. So the CO oxidation takes place another way, by the so-called bond and Thomson mechanism that is similar to the Barzan-Krevlin type of mechanism, which says that it is the oxide from the support that actually oxidizes the CO. Okay, so the oxygen that is being supplied, it's just to replenish the oxide surface. Okay, so we have here the results for gold on commercial ceria, that is here. Okay, the gold on exotemplated series prepared with carbon, activated carbon, is a bit better, okay? But if we use Shirogel, okay, Shirogel, it's made by formaldehyde, okay, and resorcinol, they are put together and then form a Shirogel. So it doesn't have ashes. And we see that these ashes from the activated carbon, they decrease the activity. If we oxidize the carbon, deactivated carbon, by treatment with acid, we see that the activity is better, similar to the one of the Shirogel. So here are the results that we obtained from the ashes, okay? The oxidized carbon samples have less ashes. So if we compare here the gold nanoparticle size on commercial area, okay, it's smaller. They have the smaller gold nanoparticle sizes. However, they are not the most active. You see here. If we compare here the sizes, these sizes here are larger than on commercial series. However, they are more active. So you see, it's not only the gold nanoparticle sizes that matters, okay? It's not the activity, just not only related to that, but also with the type of carbon material used, okay? And usually these ones that have a better reducibility of oxygen, they have also better results. Okay, here we perform the experiments without oxygen in the feed for the CO oxidation. This is just serum material. And we see here, without oxygen being supplied, this CO oxidation takes place because CO2 is being formed, okay? Then it decreases. Why? Because the surface, the oxide surface is free from oxygen. It's being reacted with CO, so it eventually decreases. So we have here, we have here a relationship. We found a relationship between series catalyst activity measured in terms of CO conversion into CO2 at 400 degrees and the amount of CO2 formed at 400 degrees without oxygen in the feed. So we can see here a relationship. If we do that for the gold-containing samples, we find also a correlation, a relationship, not really a correlation, okay? This is not 0.999 square R. No, it's just a tendency. We look at this, we see more or less a tendency between the temperature of the first peak of the TPR and the activity measured at room temperature, okay? So here we have gold on several oxides. We have here copper, nickel, and yttrium and lanthanum oxides, okay? And we see here that the most active is gold on nickel oxide. If we see the onset temperatures, copper oxide should be the most active, which is not, in fact. So if we look here at the size of gold, we see here that on nickel oxide is smaller, okay? The yttrium oxide and the others have gold 0. Here it's gold 3. So on yttrium oxide, maybe it's the gold 3 that is hindering the catalytic activity. This is for nickel oxide. You see here at different temperatures. This is just at room temperature, the specific activity. Here is at more temperature. So we see that the activity is related both with the nanoparticle size and also with the reducibility, with gold 3 being detrimental. With iron support here, for example, we have commercial iron oxide. We have here nanostructured iron oxide obtained by calcination, okay? So we obtained much larger gold nanoparticle sizes on the commercial sample than on the nanostructural sample, and this was reflected in the catalytic activity. So you see here that gold on nanostructural oxide was much better, okay? And this is compared with the World Gold Council reference catalyst, so these ones were better. For example, here gold on cerium doped cryptomalane. So that's interesting. Cryptomalane is here. OMS2, it's the KMN8016. Okay, it's an octahedral molecular sieve type of material. And see here, this might look like gold nanoparticles, but in fact, it's cerium oxide. If you want to see gold, only with this contrast technique. So if we compare here the activity, we see that this is gold with cryptomelane. So cryptomelane alone and cryptomelane with gold is the same. So we add gold to cryptomelane, nothing happens. If we had cerium to cryptomelane, the activity decreases. Okay. But if we had gold to the cryptomelane with cerium, so you see here this large increase. That's interesting. So we wondered, okay, maybe with cerium oxide, it's enough. The cryptomelane doesn't do anything. But no, we tested. So gold on cryptomelane, not good. Gold on cerium oxide like that, and on cryptomelane with cerium oxide, it's better. So if we compare the gold side, so here on cerium oxide is smaller, but it doesn't matter because it's not so active as it is on cerium cryptomelane. So what we found out is that cerium increases the number of defect sizes. Remember before, also with the copper samples, the defect sizes were good for the activity. So these sizes anchor the gold nanoparticles and enhance the charge transfer, okay, between gold and cryptomelane. Now another reaction in which we use both of the materials, the oxide materials and the gold nanoparticle supported oxide, metal oxide. So here the VOC, volatile organic compounds, they are emitted from industrial processes, transportation, and have contributions to air pollution. They are toxic, malodorous, they cause ozone depletion, spot formation, so only bad things. Two examples of VOCs are ethanol, toluene, and ethyl acetate. So the thermal oxidation of VOCs usually takes high temperatures and produces NOx from the nitrogen from air because high temperatures are used. So that is bad. If we use the catalytic oxidation of VOC, it operates between 250 and 500 degrees, so lower temperature. So the production of NOx, nitrogen oxides, is lower and less energy is needed. So that is good. So we have here a comparison of exotemplated single oxide. Okay, so we have here the commercial samples. Okay, they are in black. So copper oxide commercial iron oxide, cobalt oxide, and nickel oxide, the commercial samples. Okay, we have here. And then we have the exotemplated samples with activated carbon. Okay, they are worse, as we saw, because of the ashes. And we have the exotemplated samples prepared with carbon aerogel, okay, which are better, as we see here. So this one, the copper oxide, and the cobalt oxide is the most active one, okay? It's the most active one. And it's interesting because here it maintains the activity while the commercial sample deactivates a little. So we will see. So we made a durability test. So we see here at 235 for up to 75 hours. So we saw that the samples prepared with carbon aerogel, it had a good stability. It continued. While the commercial sample started to decrease, deactivated. It was due to sinterization of the particles. We did recycling tests, and we saw that from the first cycle to the other cycles was a little bit of loss of activity, but even so, it was not so bad. So it was quite durable. Here we have a relationship between the activity for the temperature at 100 conversion and the reducibility. So the onset temperature of the TPR. So we see here more or less this relationship. Okay. Here between the T50 and the TPR onset temperature. So we were trying to find relationships between the temperature, between the onset temperature of the TPR, etc. So to find if they were correlated. So here we have results from ethyl acetate oxidation. It's the same block as before. For lanthanum cobalt mixed oxides. Okay, so we have here the commercial lanthanum oxide and commercial cobalt oxide, and prepared with carbon gel, so the exotemplated. And here we have also exotemplated mixed oxide samples, and here the evaporation. This is just prepared by evaporation, and this was the best result, 1 to 2 lanthanum oxide, so more cobalt than lanthanum. So these were the results. And we obtained, again, a correlation between the activity and the reducibility by the TPR onset temperature. So here in white are the single oxides, and here in black, this is two samples, are the results of the mixed oxides. So you obtain, again, a correlation between reducibility of the single oxygen. Okay, this might seem a little bit complicated. It's too many samples. It's for cerium mixed oxide samples. So cerium with cobalt, cerium with copper, cerium with nickel, and also the single oxide. So we saw this is a very broad, dispersion. But if you see the samples that are here on bold, okay, the points in bold are for materials that have a higher DAT surface area. Okay, so with these ones, we can say there is some relationship between the activity and the reducibility. So it's not just reducibility, it's only the surface area that is important here, because the others are more or less first. Okay, we have here again acetyl acetate oxidation, but now it's copper on the rare earth oxide samples. So here on cerium oxide, gadolinium, samarium, and lanthanum oxide. So we see here that on cerium oxide was the best result. Okay, the best result. Again, correlation both between the T50 and T90. So the temperature of 50% and 90% conversion, and the reducibility. So you see here this relationship that we found. Also for the oxidation of toluene, okay, for cerium cobalt, lanthanum cobalt oxide samples. So we have here samples prepared. Okay, somebody is drawing things. So we have here samples prepared with carbon gel. This is the gel, normal gel. This is the gel with larger pores. Okay, so with larger pores was one. So we see that the evaporation method is better than this one here, for the lanthanum. But here for the cerium cobalt, this one, the gel with larger pores was best. So here it was the opposite. So that's interesting to see these different results. So we did a stability test of the sample with the best catalytic activity, and it was quite good, up to 75 hours. Okay, so interesting. We also did ammonia TPD profile. So ammonia is absorbed, and then we make a distortion. And so the area under the TPD curve reflects the amount of absorbed ammonia on acid sites. So the temperature of the maximum distortion reflects the relative strength of the acid sites. That means that there is an increase in the strength of acid sites with the distortion temperature. Okay, so we see that the amount of ammonia dissolved from the sample, the CXN sample, okay, is much larger compared to the others, especially compared to the other samples. The LACO sample is different. So these ones have less strength. The acid sites are weaker, shall we say. And then we see again this comparison, we have been doing. There is a good correlation between the catalytic activity with the reducibility. but for samples with a similar BAT surface area, because this one in white had a lower BAT surface area. So this one was like that. Also, we obtained a good correlation of the activity with the BAT surface area, but for samples with similar reducibility, because this one, the lack of CX122, is a bit far apart from the correlation, but it had a lower reducibility. So you see that both things are related. And here we also obtained a relationship, an inverse relationship between the catalytic activity and the strength of the acid sites. Okay, so we see that weak acid sites are favorable. So you see there, weaker is better, stronger is worse, but there is a correlation. So that was interesting result. Here we have copper on mixed cerium oxide samples. We added samarium to cerium oxide, and we saw that it had a detrimental detrimental effect in the catalytic activity and the reducibility. So the best sample was copper on cerium oxide. If we add samarium, it only gets worse, and with samarium is the worst at all. So you see here, there is a correlation between that activity and reducibility. So we obtained that. We also have here ethyl acetate oxidation for copper on this cerium lanthanidum oxide samples, okay, different ones with samarium, gadolinium, niobium, and etc. So we checked the XPS oxygen 1s peaks. So here, the peak at lower binding energy is the lattice oxygen peak, and at higher binding energy, surface oxygen peak. So we obtain a correlation between catalytic activity and reducibility, okay? The amount of, and also relationship between reducibility and the amount of lattice oxygen. So the reducibility is seen by the temperature of the odd-set TPR, and this one is from the first peak of the TPR. So the lattice oxygen is obtained here from the XPS. So you see, both can have a relationship with the catalytic activity. Here we have cerium cobalt oxide samples, okay? They are several samples and different amounts of cobalt. And again, we see that by the best result was obtained with 20% cobalt. So here, if we add more, it's worse. And we see again a reducibility, a correlation between the catalytic activity and the reducibility and the amount of lattice oxygen obtained by XPS. So the TPR and XPS are very two important techniques to help us with this. And finally, with bulk oxidation using gold, okay, materials with and without gold. So here we see that adding gold, the activity improves, okay? The oxidation, ethyl acetate, okay? Here, the oxidation of ethanol, the same, adding gold improves. Here, this is for toluene, okay? Toluene is the most difficult bulk to oxidize, so it needs larger temperatures, okay? And here is not, it's for manganese oxide samples. Again, if we add gold, is better. And we see that the activity is related with reducibility of the oxides, but also with gold nanoparticle size, because here, manganese oxide is more reducible than cerium oxide, okay? And the gold nanoparticle size is also smaller. And we also obtained good results with the durability test, okay? Here, for this cerium material, okay? See, it's up to 40 hours, it is very good. Here it's several oxides, okay, several oxides for ethyl acetate and for toluene oxidation, for the oxidation of two different rocks. And you see that the activity follows the trend of the TPR onset temperature. So it's exactly follows the same order. If we add gold, we see that the order changes a little bit, and it has to be somehow, it's related also with the gold nanoparticle sizes, see more or less here. And so we see that both factors are present. So we propose a Mars van Traven type of mechanism, okay, in which the role of gold is to enhance the reducibility and reactivity of the surface and increase the exchange rate between lattice and surface oxygen. Also, we did this test for nitrous oxide, which is N2O, that for a long time was considered a non-pollutant species, but in fact, it is a greenhouse gas, okay? And it has a global warming potential, 300 times higher than CO2, has a long lifetime in atmosphere. The ozone layer deflection potential is similar to that of CFCs, and it has been increasing, and so on. So we use, remember, the cerium oxide nanorods, nanopolyeder, and nanocubes. We use with cobalt, okay? With cobalt, we use to test for N2O conversion. So we saw here that similar results with CO oxidation, and again, good correlation between the catalytic activity and the amount of surface of the oxygen species. So it's here both for the samples with and without cobalt. Okay. Here we have commercial oxides, several commercial oxides, and gold was added to these oxides, these commercial oxides, by deposition precipitation. So if we do a temperature programmed reduction, here with aluminum oxide, almost no reduction, okay? Here with zinc oxide, there is a small peak, that's hydroxylation of the zinc. Here, the peak with titanium dioxide is for reduction of gold, because titanium oxide also has no reduction peaks. But for cerium oxide, we already saw reduction of surface oxygen, bulk oxygen, and adding gold makes it occur at much lower temperatures. And for iron oxide, okay, we see this reduction here. Okay, the first peak is reduction from Fe2O3 to Fe3O4. The second one is Fe3O4 to FeO, and the other one from FeO to Fe. If we add gold, then it occurs at lower temperatures. The reduction is facilitated. So we have here N2O conversion using oxides and gold on oxide. So what we see here is that the catalytic performance follows, okay, the reduction capacity, shall we say. So iron oxide is better than cerium oxide, better than zinc, than titanium, than aluminum. And the addition of gold increases the catalytic activity, but this order is maintained. So which means that the reducibility of the support is playing a very important role. So it's a key factor. But also the smaller gold nanoparticle size is, and gold plus, is beneficial. We see here that those were the best samples. So here we had this was cover of ChemCat-Chem. These two, the gold nanoparticles were used as catalysts for oxidation of alcohols and alkanes. So we have this reaction, benzyl alcohol and benzyl alcohol, used for the production of benzaldehyde and acetylphenones. They are important precursors to pharmaceuticals and plastic additives. So, for example, this species, and here cyclohexanone and cyclohexanol form the oxidation of cyclohexane. They are important reagents for the production of adipic acid and caprolactam used in the production of nylon polymers, okay? And the present industrial process for this synthesis, ketone alcohol synthesis, uses, needs very large, high temperatures. The yields are low and the selectivity is also low. So we could obtain a much higher yield with gold on iron oxide, use a very environmentally friendly green oxidant that was H2O2. So we obtain a value higher than the commercial and the high activity Light selectivity, I mean, it's very high, above 99%, because no traces of byproducts were found. And the industrial process has selectivity only of around 80–85%. So this is quite good. And of course, this one is faster in 4 hours. See, the other one with CVHP needed more time. And this one is a greener one. So again, the activity is related with reducibility. It implies a correlation between reducibility, surface oxygen, and catalytic activity. These tests were carried out at 60 degrees. Remember, the industrial process needs 150 degrees, high loads of catalyst. This was with low load of catalyst and without the need of acid, which is quite good. So here, using iron oxide, we saw here something interesting, which was a very rare selectivity for cyclohexanol formation. Usually a mixture is obtained. So no significant changes in activity or catalyst bleaching up to 3 cycles. After that, it starts to decrease. Okay, there it's due to adsorbed organic compounds that lead to the activation. So here we use for oxidation of alcohol with no solvent and no additives. So only that, this is for methyl benzyl alcohol. We obtain very high selectivities, and you see, and also high yield. We obtain here very good yield. No traces of byproducts. So the best one was iron oxide here for benzyl alcohol. For methyl benzyl was titanium dioxide as supports for gold. And we see that the presence of gold plus also seems to be beneficial for catalytic activity. Here a comparison of this oxidation of methyl benzyl alcohol. So supports without gold and with gold. So we see adding gold is, of course, much better. So iron oxide was the most active support. That's not surprising because it was the most reducible one, as we saw. However, if we see that the largest increase upon gold loading is obtained with titanium dioxide. Okay, so the soft values, turnover frequency values obtained are much higher than those reported in temperature. Okay, and here we see the recyclability of the gold on titanium oxide. So we see we up to 4 cycles, more or less. Here small leaching occurs, and here a lot of leaching, and also the size increases. So size is the larger size of the gold nanoparticles, so they make the activity decrease. So finally, some conclusions. So the reducibility of metal oxides, you see that is closely related with the catalytic activity in several catalytic reactions, okay, of both industrial transformation, so the oxidation of alcohols and alkanes, and also of pollutant mitigation, with soft oxidation and low reduction, and so on. And for mixed metal oxides, we saw that only some combinations work, because sometimes we added, like when we added samarium, it decreased the activity. So activity is mostly related with reducibility and the amount of oxygen, okay? But also the surface area of the materials can play an important role. Addition of gold to metal oxides, we saw that it increases the catalytic activity, but the role of the support, especially its reducibility, is fundamental, as we saw. So the oxides actively participate in those reactions. So we can say that more metal oxides and gold catalysts have a golden future. So some acknowledgement and some comments. Okay, that this I saw this article that unfortunately women are less likely to be included as authors on scientific papers. A study found. Okay, women participate a lot, but then they don't have their names on the papers, and that is very sad. We have to invert this tendency. It's, of course, not good. And to say also to strengthen that, I'll say that I am special. There is special issues in which I am the guest editor in this case of International Journal of Molecular Sciences. So this related to molecular research and application of nanomaterials. So both men and women are most welcome to send papers to this special issue. Also, this one of catalysts, nanocatalysts towards energy transition and environmental sustainability. I'm guest editor together with Professor Michalis Konsolakis from Greece. So you are also welcome. And also this one, International Journal of Molecular Science, special issue dealing with bio-nanopesticides. And also some comment here that was published in Nature, okay, saying that journals invite too few women to referee. So according to Publins, the data was available only until about 2 years ago. Now Publins merged with Web of Science, so it's all together. But before they had a ranking of referees, and in that ranking, I was one of the female referees with more refereeing done in the world. Okay, then I was first, then I became second, and now the ranking is no longer available. But I still gladly am very much. I have many invitations to referee, but unfortunately, it doesn't happen to all women, and because men usually are more invited than women. So let's also invert that tendency. So I do a call for referees for journals in which I am also part of the editorial board, like CatChem, Frontiers, Scientific Reports, Catalysis Today, etc. So these ones I can suggest names of referees, but doesn't mean that they are accepted. But here, Scientific Reports, if you want to volunteer to be referee of Scientific Reports, then papers that are given to me as editor, then I can suggest the referees, and usually the names are accepted. So if you are interested, send me an email with your data and I can propose you as referee. Both men and women are welcome. And finally, just thank you for your attention and make you an invitation to visit Portugal. It's a very nice place. So thank you for your attention.
Thank you very much, Sonia Madam, for your such an informative lecture. Now this session is open for a discussion. Dear participants, if you have any queries, then
yes, I want to ask the questions.
Sure.
Myself, Dr. Pankaj Kumar Singh from IIT BHU. Madam, your presentation was nice. Regarding the title that you have taken, that is the gold versus novel free metals that you are considering that. Then I want to ask why you have considered only the gold. There are so many other novel metals also. Why not you have considered those for the comparison of your study?
In other studies, there was a study in which I tested both gold with other noble metal catalysts, and we made a comparison, and we saw that for metals impregnated, of course, palladium and platinum were better than gold, but
yeah.
For normal methods for gold preparation, gold was more active than the other. Okay, so it was. I did not show those results, but yes, it was like that for few oxidation. Gold was more active. Well, why I use gold? It was a subject that I got very much interested in, because before some years ago, about 20 years ago, before gold was considered inert. So it was a very interesting discovery that gold could be active. So I got very much interested in the subject, so I began to study a lot of gold. So that was the reason.
Which one is better? As your topic shows that gold versus non-noble metals that you are saying that. Which one is better? Gold should have to be replaced.
Yes, well, we saw that the gold can be more active than the noble metal-free catalyst. Okay, so the thing is that gold is more active, but gold also deactivates and also is more expensive. Okay, so it has these two it has these two faces of the coin, you know, it's good, better on one side, it's worse on the other. So if we can use other replacements for gold, like these other catalysts, we can see that they are durable. So you saw that the durability was larger for several hours. The problem is that they are not so active as gold is. So we have to try to get better materials that are very active, and that is the challenge. So we say, but yes, gold needs to be replaced. Yes, that's true. Gold and
another thing that you are showing that gold you are combining with the others, all they're like the ceramic materials you are using, lanthanum and other things area. Okay, and one time you are saying that comparatively you want to show both of these, but why you are combining both of these? I know that gold is enhancing the process, that I know, but why you are showing the comparative with the gold versus the mixture? Just stop mixing, just show the, I think what I suggest, you show the comparative gold nanoparticles versus that the other noble metal or non-noble metals that you have to, I think you should have to add in your study.
Yes, we are always open to suggestions. So I thank you very much for your suggestion. It's quite good.
Okay, thank you.
Thank you. I see here that somebody is asking, did you check the morphology and the surface area after reusability? Okay. In some cases, when we have this, where we had the loss of activity, okay, we went to check what was the reason. And in some cases, we saw that it was leaching of the catalyst. And in other cases, what we saw was that there was increase, especially with gold, that there was increase in the gold nanoparticle size. So we checked the gold nanoparticle size, and we also checked the surface area. We saw that there was a collapse, shall we say, of the surface of the structure. Okay, so the surface area collapsed, the pore structure collapsed. So that was the problem.
Okay, thank you, madam.
Okay, thank you.
Is there any queries?
Hello, Vijay, 1 minute. Hello, madam. You have given very nice presentation. Yeah.
Thank you.
Initially, you have given different methods for the synthesis of the nanostructured material.
Yes.
For example, so hydrothermal, solvothermal, and electrotemplating methods. I
Yes.
think best method is the hydrothermal method, no?
Yes, it was.
Synthesis.
Yes, it was, but that was, we studied these methods for cerium oxide, to make only for cerium oxide. And for cerium oxide, indeed it was the solvothermal method at lower pH and lower temperature that gave the best results. Okay, but this was for cerium. I don't know if for other materials the same would happen. Okay.
No, all these methods are good. Yeah, but hydrothermal is the best one. Yeah.
Yes, that was for this case. It was for
Yeah.
cerium oxide. Yes.
Okay. Okay.
Gurnule sir, namaskar.
Sir, namaskar. Hello, Pankaj Singh sir.
Yes, sir.
Good afternoon.
Good afternoon, sir. How are you?
Fine. Yeah.
Thank you.
May I ask a question, ma'am?
Vijay, only one.
Okay. Okay, last question. Please ask, ma'am.
Yeah. Am I audible?
Yeah.
Yes.
Good evening, ma'am. It was a nice presentation. In order to mitigate the pollution, the work you have carried out is very nice. It's worth quoting. Ma'am, I wanted to ask you something. Like, does gold nanoparticles show fluorescence? Because in some of the part, I'm saying not of the oxides. It's only just a plain. You can say only the gold nanoparticles. Do they show fluorescence? Can you give me some interpretation on this part? because some of the when I have gone through many of the papers, in some of the papers they are showing yes, they show, and some they say that it is not. What could be the possible reason, and why is it so that there are different kinds of answers? Can you guide me in this part, ma'am?
I did not really. I could not hear you very well. The transmission is not very good. I could not understand. You said there were differences, but I did not understand what differences you were talking about. It's between gold and gold containing and noble metal free catalysts. Is that it? I didn't understand.
Ma'am,
well.
I was studying about the gold nanoparticles. Just the core, you can say the bare gold nanoparticles. It was said in some of the papers that gold nanoparticles shows fluorescence. They fluoresce. But in one of the papers, I could get the contradicting answers that no,
Hello,
it does
madam.
not show.
Sonia, madam.
Yes?
Madam is asking about the fluorescence about the gold nanoparticles.
Yeah.
Madam has a confusion. In some papers they have mentioned, but in some other not mentioned.
What is the correct answer?
But you mean the size?
No, fluorescence.
Fluorescence, phosphorescence and fluorescence.
Yes.
Yeah.
Well, I don't work with those fluorescence techniques, so I cannot really answer that. Okay. Yes, because indeed they can have fluorescence. So, but it might be that it is important in some studies and in others is not so. In some other studies, they don't mention it. They ignore that characteristic of the gold nanoparticles. But I don't work with it, so with that part. So I don't know. I'm sorry. So I'm sorry, I cannot give a good answer.
That is different part.
So I was just checking here some questions.
so
So
much.
it's saying, thank you. So it's saying here the best way to stabilize the best sample you have. Well, we saw that the oxide samples, they were quite stable. They don't need anything, shall we say. Now the gold samples to stabilize, well, that is indeed of a problem. And it might not be possible to stabilize, but perhaps, well, preventing the samples, the gold nanoparticles from aggregating, well, sometimes if we use some, it's kind of challenging. It's kind of complicated. Protect the sample from any change during the reaction. Well, it might be complicated. I mean, if we use environmental reactions, conditions that in which we have lower temperatures, for example, because gold sinterizes at higher temperatures. So if we use reactions at lower temperatures, at room temperature, then we could obtain a larger durability. I mean, so this is just I think that's the only thing we can do. Feedback link. You mean my email? Is that what you are asking? I don't know.
Okay, so no problem, madam. We can share your
Ma'am, one more
email
question.
with sorry, madam. There is a time limitation.
So I'll write it here.
Okay, so
if you want.
that discussion may be
Somebody
done
wants
later.
to send me
Okay.
an email for whatever reason it is, then please.
Yeah, you can have her email address from the chat box. So thank you, madam, for such an informative lecture and taking us to the nano world.
For your attention.
Okay, thank you once again, madam. Now our next speaker is Professor Clady Completo from Institute of Chemistry, University of Philippines, Los Banos, Laguna, Philippines. So before her talk, I would briefly introduce her. Madam, Sonia, madam, please, you can stop your sharing the slide. Okay, so Dr. Glady Completo is a Professor 9 and University of Philippines Scientist 2 at the level of at the Institute of Chemistry, University of the Philippines, Los Banos, where she was recently appointed as a director. She is an affiliated faculty member of the University of Philippines, Los Banos Molecular Biology and Biotechnology Department. the Institute of Human Nutrition and Food, and the University of Philippines Open University. Dr. Campito also served as a division head of the Control and Prevention Division at the UPLP Zoonosis Center and has held visiting professor positions at the University of California, Davis, USA. Recently, she was appointed adjunct visiting professor at Kohsing Medical University, Taiwan. Dr. Campito research focuses on drug discovery, including the design and synthesis of probes and inhibitors for tuberculosis and cancer, glycoproteomics for lung cancer, biomarker discovery and mass spectroscopy-based omics, approaches for finding glycosylated bioactive compounds from endemic plants, and industrial byproducts for functional foods. She has received several awards, including the KKPST Outstanding Research Award, University of Philippines Scientist Award, University of Philippines Los Banos Centennial Professional Chair, and one University of Philippines Professional Chair Award for Outstanding Teaching, Research and Public Service. Dr. Campito completed her bachelor and master in chemistry at University of Philippines Los Banos. Then began her PhD in organic chemistry at Ohio State University under the mentorship of Professor Todd Lowry. She later moved with Professor Lowry to complete her PhD at the University of Alberta. Afterward, she joined Professor James Paulson's group at the Scripps Research Institute as a postdoctoral fellow in glycobiology, followed by research in medicinal chemistry with Professor Michael Jung at UCLA. She returned to UPLP, that is University of Philippines, Los Banos, where she now leads the glycobiolab and mentors graduates and undergraduate students. Dr. Campito is an associate editor of SciEngineer, a WOS and Scopus Index journal, and is a current president of the Philippines American Academy of Science and Engineering, that is PAASE. So we have such an eminent speaker today. So I request Professor Clady Campito Madam to deliver her talk on building a more equitable future, the potential of oligosaccharides in combating malnutrition. So please, madam, over to you.
Thank you very much for that introduction. I would like to share my slide now. Okay, so as I mentioned, although the professor introduced me by mentioning several projects that I've been working on, I'll be sharing with you the most recent project that I've been doing, and is on the formulation of potential oligosaccharides supplement in combating malnutrition. So can you hear me properly?
Yes.
Okay, so let me start with this number, 1,000. This number represents the first 1,000 days of life that starts from conception and up to the second birthday of the child. And this window is essential for the child's brain development, growth, and immune system, which is very crucial that the mother and child receive adequate health care and nutrition. And how will this be achieved? The World Health Organization recommends exclusive breastfeeding for the first 6 months of age. And there are several laws that exist in our country, such as the Milk Code, the Expanded Breastfeeding Promotion Act, and the Kalusugan at Indusyon ng Magnanay Act, all designed to ensure the nutrition of pre-pregnant, pregnant, and lactating women, as well as infants and young children. Yet, very few mothers exclusively breastfeed, and most of them belong to low-income families. Filipino mothers have a number of reasons for terminating breastfeeding, and notably the perception of inability to produce enough milk, which can be linked to poor nutritional status. Let me share some pictures of children under the age of 5. This is Jomar Bakaltos, who suffers from severe wasting. And here's another child, Trista, who is stunted. She's a 2-year-old daughter. And the reason for this, as you can see in the picture, even the mother is also malnourished. And they also think that infant formula is much more healthier compared to breast milk. So, and this is not just happening in our country. Globally, 22% of children under 5 are actually stunted. So statistically, 1 out of 4 Filipino children below 5 years old is stunted according to our statistics. And I also look up the statistics in India. Apparently, 35% of India's 137 million children under 5 are also stunted, with over a third also underweight. What's more alarming is, aside from the huge number of children suffering from undernutrition, such as stunting and wasting, increasing numbers of children and their families are also affected by overweight and obesity. And one reason for this is the very poor practice of breastfeeding among lactating mothers. Because of this, our country is actually losing a lot of money due to stunting. We are losing $5 billion per annum due to childhood stunting. And this calculation is based on GDP affected by workforce productivity and education, and additional costs to cover repetitions due to undernutrition. And as I mentioned, this is not just happening in the Philippines or not just happening in India. It is happening globally. You can see here that in this graph that undernutrition actually costs the world at least $761 billion per year, or $2 billion per day. And what are this? Due to stunting, low birth weight, anemia, and suboptimal breastfeeding. So clearly there is a problem. And one cause of this undernutrition is the very few practice of mothers that are lactating. So there is insufficient reinforcement of breastfeeding among Filipino population. And I think that is also a problem in India. And most mothers are not knowledgeable on the benefits of breastfeeding. And one reason for that is the aggressive campaign of companies, which claims that infant formula are clinically proven to give the IQ and EQ advantage. Because of this, when we started our projects, we conducted seminars on breastfeeding. We wanted them to learn the benefits of breastfeeding their infant. And we wanted to answer these research questions. One research question is, we're particularly interested in one component of the breast milk, which we call human milk oligosaccharides. And what is the profile of HMOs in the mother's breast milk for Filipino mothers? And then we wanted to know, do food intake and environmental conditions affect HMO composition? And are there possible sources of specific HMOs that can be utilized as supplements or fortificants? So I would like to share first the first part of this talk, wherein we determine the comprehensive human milk oligosaccharide composition or profile from Filipino mothers. But let me just share with you first, why is breast milk the perfect nutrition for infants? If you look at the composition of breast milk, it's mainly composed of lactose, followed by lipids and proteins, and this component, human milk oligosaccharides. It is even sometimes the concentration of HMOs is higher compared to that of the proteins. And what are these HMOs? It is based on this, it is built on the lactose structure. Here is a representation of an IUPAC representation of the lactose structure, where it is based on different shapes and colors. So here you can see that glucose is colored blue in circle form, galactose is in yellow, and if there's an acetyl group at the second position, it becomes a square, and then glucose is in triangle, red triangle, and acetylnuraminic acid or sialic acid is drawn as a diamond, a purple diamond. So you can see here that this is the basic structure of an HMO, where there is fructose. And so when it is connected to sialic acid, it is termed as sialylated. And if there's a fucose structure, it is termed as fucosylated. And some of these are neutral ones. And you call them, when there are no other structures, non-fucosylated neutral HMOs. There are more than 200 HMOs that have been identified already. And what's very interesting about a pointer, yes. What's very interesting about HMOs is that they are actually indigestible in the infant gut. How come? So what's the role of HMOs if they're indigestible? They have a lot of important functions. Let me share with you. First is HMOs promote the growth of selective bacterial species responsible for production of short-chain fatty acids. So HMO act as metabolic substrates that promotes growth advantage of this microbiota and thus considered as the first prebiotics for infants from day one of life. So some possible bacteria present in the gut include Lactobacillus, Clostridium, Eubacterium, Salmonella, and Enterococcus. But only Bifidobacterium and Bacteroides species were able to consume HMOs as a sole carbon source and achieve high cell densities. So that's one main function of HMO. They serve as prebiotic for beneficial bacteria. Another function that HMOs perform is that they act as decoys by protecting the infants by inhibiting the binding of pathogens to epithelial surface. Because infection can only be effective if the pathogen, either in the virus form or bacteria or protozoa, can attach to this epithelial cell surface called glycocalyx. And these pathogenic microorganisms can proliferate, invade, and oftentimes cause a disease. And these HMOs mimic the natural ligands of the pathogen, serving as soluble decoys. Thus, by blocking the binding or attachment of the pathogens of these unbound microorganisms cannot attach and are washed away, preventing the infection to happen. So HMOs that include structurally similar isomers, subunits, act like soluble decoys that resemble the structure of glycocalyx, thereby blocking binding or attachment of the pathogenic microorganisms. Another function of HMOs is that it doesn't only serve as soluble decoy, but it changes the expression of the glycocalyx receptors by reprogramming the epithelial cells. They alter the intestinal epithelial cell gene expression, leading to the changes in the cell surface glycocalyx and thereby inhibiting the attachment of the pathogen. And one more important function of HMO is that it can promote postnatal brain development. You can see there are sialic acids present in HMOs, which can help in the brain development of the child. So how did we determine the profile, the HMO profile of the breast milk from our volunteers? So we're able to collect more than 155 breast milk samples from mothers, volunteer mothers. And how did we determine the profile? We use this rapid throughput milk mass spectrometry-based glycomics. So the protocol involves lipid separation via centrifugation using ethanol, then alditol reduction with sodium borohydride, and a final solid phase extraction purification step using graphitized carbon cartridges. He is then injected to an LCMS instrument where, based on the retention time and the molecular features using the Mass Hunter software, we were able to identify the HMOs present in the breast milk samples. I just want to emphasize here that this method is very efficient. It is considered as a new analytical method for determining the oligosaccharide present in the sample. You can see here that in terms of sample preparation, it only takes a few days. And does it need derivatization? No, if we just want to determine the oligosaccharide analysis. But if we want to do the linkage analysis, of course, we have to derivatize it. But in terms of the detection, it can detect up to the femtometer. We use high throughput by just using 96 wall plate. And in terms of baseline separation, we don't need that. And in terms of separation time, we can even see a separation time of 2 minutes up to 16 minutes. And in terms of the number of hours that we need to analyze the oligosaccharide composite profile, we only need 3.5 hours. But in terms of linkage analysis, we need more than that. And these are the papers that we have published showing the protocol in determining the profile of the breast milk for Filipino mothers. So it turns out that the production of human milk oligosaccharides are genetically determined. So there is what you call secretor mothers and non-secretor mothers. And secretor individuals secrete ABH antigens in their bodily fluids, such as saliva, blood, tears, and in our case, breast milk. We didn't have to get blood from our mothers. We just needed breast milk from them. And we noticed that secretor mothers produce 2' FL in large amount compared to non-secretors, while the non-secretor mothers produce these large amounts of these HMOs. And this is because of the presence of the enzyme that is responsible for the attachment of this fucose unit. So we were able to identify more than 200 HMOs. As you can see here, these are the most prominent ones, 2' FL and the LNT and LNNT neutral oligosaccharides. So we were able to determine the phenotypic secretor status of Filipino mothers, and it turned out that 81% of our volunteers are actually secretors, and only 19% are non-secretors. You can see here the difference in the composition of the HMOs. For the secretors, they, of course, produce a lot of 2' FL, while the non-secretors produce LNNT and LNT, and also sialylated oligosaccharides. So is this unique to Filipino mothers, or are mothers from different countries also produce same types of HMOs? Are there also mostly secretors or none, unless that of non-secretors? So we compared our results from the results of other countries, and this is the comparison. You can see here that most mothers actually are secretors. Okay, there is the secretor status distribution among different populations in the world, suggests a multitude of factors such as geographical location. But you can see here that although I apologize, I don't have data for mothers from India, but you can see here that most mothers are actually secretors, and around 20% are non-secretors. And for the secretors, you can see here that they mostly produce fucosylated HMOs, while non-secretors produce sialylated HMOs. And we also tried to check longitudinally if in terms of production of these human milk oligosaccharides. And it turned out that HMOs actually production decreases across lactation, which makes sense because when it goes to around 6 months or more than 6 months, infants actually are being given solid food. So that's why they don't need HMOs anymore. As you can see here, at the start, they produce a lot of HMOs and it goes down. And these are all statistically different. Another factor that we wanted to check is is there an effect in the age of the mother? Mothers, do young mothers produce more HMOs, or do older mothers don't produce enough human milk oligosaccharides? As you can see here in our graph, that there's no difference. It doesn't matter if you're still young or you're a little bit more than 35 years old, you will still produce diverse HMOs that are needed by the infants. So this is the most comprehensive profile of HMOs that was reported in the Philippines. And then the next question that we wanted to answer is, do food intake and environmental conditions affect the human milk oligosaccharide composition? So what we did was we did a study where one of my students went to this part of the Philippines. It's called Baybay. Baybay owes its name, which literally means seashore, to having the longest coastline in Leyte. And we collected breast milks from mothers living near the coast and mothers living in non-coastal area. And we collected breast milk starting from first month up to 9 months. And we compared the HMO profile. And it turned out that not all mothers biosynthesize the same set of glycans. And we know that because it is determined genetically, right? But apparently, the environment and the type of food that mothers take actually affect the HMO production. So here, we can see that the coastal mothers produce high abundance of fucosylated HMOs, while those living the non-coastal area, though there is no significant increase in the fucosylated human milk oligosaccharides. And why is that? What's the possible reason for this? Why do coastal mothers, according to our observation, according to our data, produce more of fucosylated human milk oligosaccharide? Turns out that these mothers eat seaweed every day. And seaweeds are composed of fucoidants, which are source of fucose that can be introduced into the biosynthetic pathway in preparing HMOs. So we were able to show that aside from secretor status, the coastal environment may also influence fucosylation of the human milk oligosaccharides. And this could be attributed to the regular food intake of seaweed, which is known for its high fucoidant content, a source of fucose, and this fucose can be incorporated into the biosynthesis of fucosylated glycans via the salvage pathway. I just want to show you all of these human milk oligosaccharides that we were able to identify and annotate. So from this study, we were able to show that, yes, environmental factors can affect, and this is not the only study that was able to show this. Another paper from Japan was also able to show that by the continuous intake of fucosylated oligosaccharides, then the HMO profile also was affected. But as you notice, we cannot keep on getting, the source of HMOs cannot be just breast milk. We wanted to determine what are the possible sources of human milk oligosaccharides that we can use so that we can come up with a supplement and that can be a source of, these HMOs. So what we did was we used buffalo cheese whey, a byproduct of cheese making. And these are, and let me just show you the comparison of the composition of buffalo milk with cow's milk and human milk. So here you can see that here's the human composition, the cow's milk and buffalo milk. So you can see they're very similar in terms of composition of proteins and of course lactose, but buffalo milk has higher concentration in terms of fats. But when it comes to oligosaccharides, of course, HMO concentration in human milk is much, much higher than the oligosaccharides present in bovine and buffalo milk. The HMO concentration is actually what? 100 to 100 times fold higher than that of oligosaccharides present in bovine milk and also in buffalo milk. But if you notice, the basis of formula milk is usually bovine milk. Is this really a good source of human milk oligosaccharides? So what we did was, we tried to determine the composition. We tried to compare the composition of oligosaccharides present in buffalo milk, bovine milk, and human milk. And this is what we discovered. You can see here that in this study, we were able to detect 29 oligosaccharides common with human milk oligosaccharides that were fucosylated. Okay, so these for human, these are study, and these are previous studies of buffalo milk and bovine milk. And we also discovered non-fucosylated sialylated oligosaccharides that could contribute to the understanding of the similarity between buffalo milk and human milk. And most importantly, you can see that both human milk and buffalo milk does not contain N-glycolyl neuraminic acid or New5-GIC, which has been implicated with cancer development. Let me tell you some of the structures of the HMOs that we were able to identify. These are the HMOs that we were able to find in buffalo milk. And just to inform you, most of the infant formulas that are being sold now are actually incorporating HMOs. They're being added in infant formulas. You can see here, these are all these are brands that just being sold in the Philippines. Also, these also being sold worldwide. Okay, you can see these the first HMO that they added, the 2'-FL. And then now Similac is now adding 5 HMOs, the fucosylated and sialylated oligosaccharides, because we, as I've mentioned earlier, sialylated oligosaccharides are very important in the brain development of the child. So what are the possible source? In the Philippines, whey is a waste product, as they say, as most of you may know, it's a waste product of cheese making. But unlike in Western countries, our whey byproduct is not being utilized effectively. It is just being thrown away and not being produced as another product. But you can see from the composition, you can see that it is highly nutritious. So we compare the composition of whey to that of the human milk. You can see here is very similar, right? Of course, it still has lactose. It also has proteins and lipids, but of course, buffalo whey has oligosaccharides, but still human milk has much more. These are the major components of whey. The milk oligosaccharides, we have fat globules, casein micelles, and whey proteins. So why do you want to use this whey byproduct? Because it turned out that the missing link, why interventions are not very effective for catch-up growth of stunted children, because of the immaturity of the microbiome of these children. So our framework involves isolation of prebiotic milk components in whey byproduct using ultrafiltration and concentration, and taking advantage of these prebiotic properties for microbiome recovery, and which could lead to the catch-up. We hypothesize that gut microbiota plays a vital role in catch-up growth of stunted children. So this is first, we characterize the oligosaccharides present in the buffalo whey byproduct, and we analyze and quantify this. And then we did in vivo evaluation And we also wanted to determine the mechanism of action of these oligosaccharides. So we did in vitro evaluation and did metagenomics to identify the bacteria present in the stool of the stunted mice, and also the stunted mice that were given the interventions that we have prepared. So here's a just a video of, I hope I can, no. This is just a picture of the ultrafiltration that we are using. Okay, unfortunately, I cannot play it. So we were able to produce 3 different types of supplements depending on the method that we, and depending on the membrane that we use. We produce either a protein-rich, oligosaccharide-rich, or we combine them, oligosaccharide and protein-rich supplements. So our process can produce 3 types of supplements. So here's the method to produce the protein-rich. And here's the method for oligosaccharide-rich. And method for the combination of oligosaccharide and protein-rich supplements. These are our supplements that we were able to produce. And we also determined the composition, you can see here. And we did LC-MS-MS, and we were able to identify these human milk oligosaccharides present still in our whey samples after the ultrafiltration. And this is compared with the standards. So you can see that we were able to actually see all those important human milk oligosaccharides that are being added in the infant formula that are being sold these days. And this was quantified, and these are the mass spec data. And we were also able to identify novel, complex, fucosylated, sialylated oligosaccharides that were present in our whey samples. So after that, we wanted to determine the prebiotic effect of our samples. We tested it with the Lactobacillus plantarum, and you can see here that there is growth stimulation. Of course, maximum growth stimulation was observed for that of the mice that were fed with human milk, okay? And then followed by the protein-rich whey oligosaccharides and lactose-free oligosaccharides. You can see that there's a stimulated exponential growth phase for the Lactobacillus plantarum in the presence of all of these whey components. That means that it can enhance its survivability in the gut. Okay, to produce some effects, positive effects on the health of the gut, we were able to show this. And we also identified, okay, that there is a significant increase in the growth kinetics, indicating the functional properties of the formulated whey powder. And the Lactobacillus plantarum actually utilize specific glycans found in the whey. So you can see here, it utilizes the Lactobacillus plantarum. It has preference for glucnac and sialic acid and other neutral oligosaccharides. So we actually determined, before, I don't have time to show you, but we actually optimized different stunting models before we incorporated the supplements that we were able to formulate. So the steps in the in vivo experiment, we had to mate and gestate them, and we gave lactation and restricted feeding to induce stunting. And then we incorporated feces samples from stunted children, okay? And then that's when we added our supplements, and we collected urine, feces, and blood from these mice based on the different interventions that we did. So here's just a sample of our results. You can see that the restricted mice suffered severe malnutrition, as indicated by the weight for age, before supplementation. You can see here because we induced stunting. And you can see that after 1 month, the control was 20% lighter compared to that of the normal reference. And a supplementation with a protein-rich supplement, POS, OS, resulted in weight catch-up as early as the 2nd week versus the 3 weeks with optimal feeding. We also determined the in vivo growth effects. This is the BMI for age. You can see that the growth catch-up occurred slower than the weight catch-up 2 weeks during supplementation. And both weight and linear growth were corrected by supplementation with human milk and protein-rich oligosaccharides. You can see that there's a linear growth that was observed for the whey oligosaccharide despite a slight weight deficiency. We also determined some of the, we compared the weight for age gain and BMI for age gain. You can see that stunting and wasting can be linked to the gut microbiome with possibly different mechanisms because of the different varied significance in terms of the different, by comparing the 3 different interventions. You can use another. We also determined the plasma clinical chemistry by determining the urea composition, protein, and AST and ALT. And then you can see here, okay, these are the negative control, that there is an elevated ALT activity in the blood, indicating potential serious liver damage. So, and we also determined the microbiome from the stools collected from this several groups, from these different groups. And you can see that there is an improved gut microbiome diversity for in stunted mice from week 1 with sustained improvement through week 3. And this suggests that whey powder's potential to counteract gut microbiome diversity.
मल्टीप्लाई क्लियर है?
Yes,
मल्टीप्लाई अच्छा मल्टीप्लाई 2 नंबर का मिलेगा कल 7 कल 7 का
able to determine that the cheese whey powder prevented pathogen proliferation. You can see here the growth of
2 नंबर का मल्टीप्लाई
and this Escherichia microorganism in stunted mice, reaching levels similar to those in normal diet mice for weeks 3 and week 4. So this, and what does this imply? This may help prevent infections that contribute to stunting and lower early antibiotic exposure risk in children. For summary and conclusion, we were able to show that ultrafiltration recovered milk oligosaccharides and sialylated glycoproteins from Casein-Petit whey, and prebiotic and growth effects of functional foods compounds present in whey powder have been confirmed in vitro and in vivo. And then these are my collaborators, and this is the team that work on this project, and this is my research group. And I just want to share with you our university, University of the Philippines, Los Baños. This is the map of the Philippines. You know that there are 3 major islands: Luzon, Visayas, Mindanao. You can see here is Laguna, where University of the Philippines is located. It's at the foot of a mountain, Mount Makiling. So this ends my presentation. Thank you for your attention.
Okay, thank you very much, madam, for a very such nice and informative lecture. Now the session is open for discussion, but just to take a note that we will take 1 or 2 questions, please.
Ma'am, there was a good evening, ma'am.
Good evening.
Yes, there was a good evening. This was very interesting and something which related me so much because it was meant for the ladies. the fact is, I could see that in one of the slides you have shown that this protein, then lactose, and protein-rich oligosaccharides were more helpful than those lactose oligosaccharides. Then the milk has the main component as lactose. One of the enzymes are lactose. One of the primary enzymes is lactose. So how is it like protein-rich oligosaccharides are more helpful than those lactose oligosaccharides? How could you explain that part?
Oh, though even the protein rich still has the lactose composition. It's not just we just present the way we presented this is just rich in protein, but still it has the same amount of lactose. So that's why, in addition to the lactose, the glycoproteins and oligosaccharides help in the promotion of growth.
Okay. Thank you so much, ma'am. It was a nice presentation.
Thank you.
Okay.
Hello, madam.
Yes.
Glady, madam, you have given very nice presentation. And just I want to have a doubt. Glycan is there. Like, what is the role of glycan in the biological process, and what is the composition?
Oh, there's a lot. Remember, so the glycans are the human milk oligosaccharides, right?
Okay.
These are complex oligosaccharides based on lactose structure, but they are more complex because it can be sialylated or fucosylated. As you can see here, let me just show real quickly. So
And
that,
what is the role here in the biological process?
oh, it plays a lot of role. As I mentioned, it acts as a soluble decoy, where it prevents the pathogens to infect the child. That's one role. Okay, here. So it acts first. It acts as a prebiotic. It acts as the prebiotic for beneficial bacteria. So they serve as the substrate for as food for the beneficial bacteria. And then it also serves as a soluble decoy because the structure of the HMOs are very similar to the substrates of the pathogens. So they inhibit the proliferation of the pathogens. And also what's very interesting, as I mentioned, it even modifies the structure of the glycocalyx, thereby preventing the infection. And last but not the least, it is a source of the sialic acid, which is a component of for our brain development. So those are the functions of the human milk oligosaccharides that are very important. And there's a lot of literature that already have proven that these HMOs actually help in preventing diarrhea. They also help in preventing virus infection of the children.
Yeah.
Okay. Thank you, madam. I think sir has got the answer.
Yeah,
Thank you
yeah.
once again, madam, for a nice presentation. Now our next speaker is Professor Anjali Rajbhoj, madam. She is a senior professor from the Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar, from the India. And she will be talking on impact of nanotechnology in the modern world. So before going to her lecture presentation, I will briefly introduce her. She has a 33 years of teaching experience and 25 years of research experience. She has completed a major research project in 2014, which was sponsored by UGC. She has published more than 150 research papers in very reputed journals. She has guided 14 PhD students and 4 are currently working under her. She is a life member of several organizations like Indian Science Congress Association, Kolkata, Indian Science Chemical Society, Society of Material Chemistry, BARC, Mumbai, and Analytical Chemistry Teachers Association, that is ACTRA, Chhatrapati Sambhajinagar. So once again, I welcome respected Professor Anjali Rajbhoj, madam, and invite her to deliver a talk on impact of nanotechnology in the modern world. So please, madam, over to you.
Thank you, Randai sir. Is my slide visible?
Not yet, madam. Please share your slide.
Just a minute, sir. Share screen. So is it visible now, sir?
Yes, yes, madam.
Yes. So thank you, Randai sir, for a nice introduction. First of all, let me thank all the organizers for giving me an opportunity for the invited talk.
Sorry to interrupt, madam. Please switch on that slide so.
Sorry,
click
sir.
on that slide. Click on that slide so.
Just a minute. I'll do it, sir. Just a minute, sir. So I would like to thank all the organizers of this, that is international webinar on accelerating equity in science, which is organized by that is Jagat Arts, Commerce and IHP Science College, Goregaon, District Gondia. Then Society for Promotion of Material Science, Nagpur, and Association of Chemistry Teachers, in care of that is Homeo Baba Center for Science Education, TIFR, Mumbai, in collaboration with IUPAC Global Women Breakfast. So I would like to thank all the stakeholders for organizing this conference very efficiently, and thank you for being that I am part of this conference. So I start my conference. The topic of my conference is impact of nanotechnology in the modern world. So yeah. So what is a nanometer? Nanometer is a 1 billionth of a meter. This is roughly 10 times of the size of an individual atom. And here the nanoparticles which we are going to study, they are in the range of 1 to 200 approximately nanometers. So your comparison is given between a small molecule which is roughly about 1 nanometers, and your plant cell is given here, which is about like 100 micrometers. So you can see the virus is like 10 nanometers in size. Bacteria, it is 1 micrometer. So this is what is the analysis given. Now, how the nanotechnology came into existence. The history, it was the first proposed the concept, that is Richard Feynman was the first to propose this concept in 1959 in his famous speech that there is plenty of room at the bottom. So this led to the that is we say that the introduction or discover, this led whatever he has said, that scientists found that we can do the research work at the molecular level. So this is what he meant in his speech. Then invention of scanning tunneling microscope in 1981 and the discovery of fullerenes, that is C60, in 1985 led to the emergence of nanotechnology. The term nanotechnology had been coined by Norio Taniguchi in 1970. So this is all regarding the history. Now again in the history in 14th century, these are the 14th century cups which are shown here. So when from this cup, when the light is reflected, it appears green, and when the light is transmitted, it appears red. So the size of this gold and silver nanoparticles here, it have been found that they are 70 nanometers. So though they in the history they did not know that this effect is because of nanomaterials, but still they could make the use of this gold and silver nanoparticles for making of different colors of these cups. Now, this nanotechnology is also found in church paintings. You can see the different colors of these churches in the, that is European countries. So this paintings, they create colors, and also these nanoparticles which are embedded in this glass, they purify the air. Many church windows across Europe were decorated with glass colored in gold nanoparticles. Nanoparticles of gold energized by the sun were able to destroy airborne pollutants like volatile organic chemicals, which may often come from new furnitures, carpets, and paints in good conditions. Gold, when in small as particles, becomes very active under the sunlight. So this was studied in the historical period, that is about 4th century. Now, the discovery of nanoparticles also was because of this Faraday's experiment. So this Michael Faraday, he prepared different colored solutions of that the particle size was 2, 5, 6, 12, 16, up to 150. And you can see that as the size of the gold particles, they changed, the color of this solution also changed. So this Michael Faraday was first to prepare the pure sample of gold, colloidal gold, which he called as activated gold in 1857. And he used phosphorus to reduce the solution of gold chloride. Here, the difference in macro, micro, and nano is given here. So on the left hand side, you can see that the macro sized are person, an apple, and ant, and micro size is like a human hair, then bacteria, and the nano size is like carbon 60, DNA, and CNT, that is carbon nanotubes. Then what is the difference between nanotechnology and materials? That is, nanotechnology is the creation of functional material devices and systems through control of matter on nanometer scale length, that is 1 to 100 nanometers, and exploitation of novel phenomena and properties. Any material that has that is what is nanomaterials. Any material that has unique or novel properties due to the nanoscale, structuring formed by incorporation or structuring of nanoparticles. So these nanoparticles are of like 1 to 100 nanometers as described. Now, what are the tools used for study of this nanotechnology? That is, you can see here it is atomic force microscope, that is AFM is given, then scanning tunneling microscope is given, then various techniques of nanolithography, they are given here, that is optical, X-ray, dip pen, electro beam lithography. This is developed, and which also developed the nanotechnology. So lithography in MEMS, that is micro electromechanical system context, is typically the transfer of pattern to a photosensitive material by selective source to a radiation source such as light. That is, it is used to fabricate an intricate electrical system on a chip. X-ray diffraction is also used in the study of nanotechnology. So it is used to characterize the crystal structure, phase composition, crystallite size, and orientation of nanoparticles, providing crucial information about the crystallinity and structural details of nanomaterials, making it a key tool for analyzing and optimizing the synthesis process of nanoparticles. So here you can see, with the help of this Bragg's law equation, here we can find out that is crystal of molecule, and Debye formula is used for calculating the. Then same method is used for examining the shape, distribution of nanoparticles, then agglomeration. Then we can also see the morphology, that is like whether they are nanoparticles or wires, tubes, or thin films. So surface coating analysis, we can even find out the thickness and uniformity of coatings on the nanomaterial. This is in the stem, and in HR time, that is stem. It is used for analyzing the size, shape, and crystal structure of individual nanoparticles. In this, we can even calculate the interface analysis, the crystal structure, the set pattern. It is that is selected area diffraction, electron diffraction pattern is primarily used to identify the crystal structure and lattice parameters of nanomaterials, allowing researchers to determine the crystallinity and the crystal orientation. Set pattern is also used to identify the crystal structures and crystal defects. So approaches of nanotechnology, how we can prepare nanomaterials. The first method is by bottom-up approach. Bottom-up approach means from the molecular level, we can prepare the nanomaterials, because nanomaterials are bigger in size than the molecules. So in bottom-up approach, different materials and devices are constructed from molecular components of their own. They chemically assemble themselves by recognizing the molecule of their own weight. So this is the example of Watson-Crick based pairing nanolithography. That is the bottom-up approach. Now in the top-down approach, from the bigger elements, we are making it to the nano-sized. So top-down approach, nano objects and materials are created by large entities without bouncing its atomic reactions. Usually top-down approach is practiced less as compared to that of the bottom-up approach. So this solid state techniques can also be used to create devices known as nano electromechanical systems, that is NEMS, which are related to micro electromechanical systems or MEMS. So MEMS, that is MEMS, become practical once they could be fabricated using modified semiconductors, device fabrication technologies, normally to make electronics. So what are the applications of nanotechnology? You can see there are many applications you can see here, from energy to cosmetics, bioengineering, defense, optical, and we'll see one by one this few of this. So in the nanotechnology in this day-to-day life. So here you can see here nanotechnology is used in information technology. That is, it is also used in energy, medicine, and consumer goods. So in information technology, smaller, faster, more energy efficient and powerful computing and other IT-based systems. So here, this can also be used for making, that is solar cells, fuel cells, batteries, and biofuels, more efficient and cost-effective technologies for energy production. Then in the medicine, we'll see this in detail, and consumer products or consumer goods, that is food, beverages, advanced packaging, material sensors, and lab-on chips for food quality testing, appliances and textiles, stain-proof, waterproof, and wrinkle-free textiles. So you can see the first application in the photovoltaic solar cells. That is, you can see it generates electricity directly from sunlight by two main types. That is single crystal silicon, which is a traditional method practiced from years. It is widespread, but it is expensive and it has less efficiency. But nowadays, we are using that is a dye-sensitized nanomaterials, which are new. They are inexpensive and they have high efficiency, flexible, and they are flexible. So nanotechnology is also used in wind turbines. That is now when it comes to the weight is reduced. That is nanomaterials which have excellent strength to weight and stiffness to weight ratios enable construction of longer, more robust blades. Energy losses, low friction coatings, and nano lubricants provide means to reduce energy losses in gearboxes and thus further increase the efficiency blades of these wind turbines. That is, nanotubes are used in these blades to make these blades stronger and lighter, improving energy efficiency lifetime. So lifetime is that is when we coat this with nanopens to increase the wind turbines lifetime. So here nano optimized energy storage, that is first is the electrical energy storage. So using supercapacitors, advanced nanocarbons, that is CNT, that is carbon nanotubes or graphene. So we can make supercapacitors from this. Carbon aerogels as nanoporous substances are suitable as graphitic electrode materials in supercapacitors because of that is this carbon aerogels. They have extremely high inner surface, power densities of more than 10 kilowatts per kg, used in mobile applications where high energy amounts have to be provided in a very short time. So this nanomaterials, when they are used in batteries, the electrodes which are there, they allow higher storage densities of lithium. So we are talking here about lithium batteries than the standard metal or graphite electrode. So carbon coated silicon wires, carbon nanotubes, layered nanostructured vanadium oxide and manganese oxide. So you can see here advances of nanotechnology in lithium ion batteries. So these lithium batteries can enhance the safety and capacity of lithium batteries greatly. That is this nanotechnology. It enhances the safety and capacity of lithium batteries greatly. It stores 2 to 3 times more energy per unit weight and volume than acid, that is lead acid or nickel cadmium batteries. They have long cycle lives, that is more than 10,000 cycles, low self discharge and longer shelf lives. They are widespread, used in electronic devices. Potential applications promise in the areas of communications and remote sensing devices. So you can see that this lithium batteries find uses in many areas, such as smartphones, laptop watches, torch lights, military equipments, aircraft, electric vehicles, and more. So applications of nanoparticles in medicine, cell imaging, detection and diagnosis, monitoring, drug delivery, gene delivery, and regenerative medicine. So this nanotechnology is also used in surgery. Minute surgical instruments and robots can be made, which can be used to perform microsurgeries on any part of the body, like vital organs, like brain, heart, and lungs, and so on. So instead of damaging a large amount of body, these instruments would be precise and accurate, targeting only the area where surgery should be done. So visualization of surgery can be improved by nano cameras, which provide close visualization of surgeries and can be done without any faults. So therapeutic applications, cleaning of mouth. So here we can see here the picture of a two teeth being cleaned here. So mouthwash, which we use in our day-to-day life, they identify and destroy pathogenic bacteria while allowing the harmless flora of the mouth in the ecosystem. So 4 remote control nanorobots examine and clean the subcallosal surfaces of patients' teeth.
अरे इसका ये भी तो ये कब खिलाएगा इधर आ ऐसे तो पेपर भी ऑनलाइन हो गया
दोनों बहन भाई एक जैसे हो रहे हैं
कब
दोनों बहन भाई एक जैसे
Nanotechnology in drugs, that is for treatment of cancer, provide new options of drug delivery and drug therapies. These enable drugs to be delivered to precisely the right location in the body and release drug doses on a predetermined schedule for optical treatment. Attach the drug to a nano-sized carrier, they become localized at the disease site, that is a cancer tumor, and then they release medicine that kills the tumor. Current treatment is through radiotherapy or chemotherapy. Robots can clear the blockages in arteries also. So here, and you can see here a picture representation here is given. That is how the nanoshells they kill the cancer cells. These are the nanoshells here, and green are the cancer cells, and the healthy cells are seen as pink. So nanoshells they attack the cancer cells and they destroy, and the cancer cells become that is dead. So this is all this process is carried near the infrared light, and the healthy cells they remain intact. So nanotechnology is also used for the application of nanotechnology in agriculture for various purposes, that is crop improvement, precision agricultural, soil management, plant disease diagnostic, efficient use of pesticides and fertilizers, water management, post-harvest technology, gene expression and regulations. So here it is given that scientists in Iowa University have utilized 3 mm mesoporous silica nanoparticle in delivering DNA to the isolated plant cells. So this technique has been applied to introduce DNA successfully to tobacco and corn plants. That is the proteins. So here it is being shown that the crop yield is improved by this method. So here again a picture is being given. That is how nano materials are used in various functioning of the plant. Then nanotechnology for waste water treatment. Nanotechnology has great potential to be used in wastewater treatment. An unique characteristic of having high surface area can be used efficiently for removing toxic metal ions, disease-causing microbes, organic and inorganic solutes from water. Various classes of nanomaterials are also proved to be efficient for water treatment, like metal containing nanomaterials or particles, then carbonaceous nanomaterials. Nanotechnology has led to various efficient ways for treatment of wastewater in more precise and accurate way on both small and large scale. So here you can see the fullerenes, carbon nanotubes, graphene and metal nanoparticles are being used for wastewater treatment. They remove pathogens, heavy metal removals, organic pollutants, then solid and liquid, that is soil solids are removed, and emerging contaminants are also removed. So here nanosorbents, they have are also used for cleaning of water. So you can see here a picture that is the orangish part is the magnetic core, and it is covered by silica, and then they are added to a contaminated solution, and they can remove the photocatalyst, then adsorbents, then also they can remove the antimicrobial nanomaterials. So you can see here, this is how the nanosorbents can remove, clean the waste water. Now, nanotechnology and environment. So pollutions, pollutants which are or in air, we can see ammonia, carbon monoxide, CO2, nitrous oxides, and then methane, H2S, then volatile, that is we can see carboxylic acids and aldehyd. All these are present. They can be removed with the help of nanomaterials by using fluorines, graphene, CNTs, that is single walled and multi-walled, and activated carbon. So silica-based nanomaterials and alkaline ceramics can also be used for this nano remediation, and graphite oxide and carbon nanotubes are used for the that is removal of the pollutant gases, and they can be used in the various polluted cities. So use of nanomaterials in bulletproof vests and body armor. So here you can see that is the armor which is used by our soldiers. They have a layering of like onion, okay, of the, that is, you can see tungsten. We don't use CNTs there, but tungsten material is be used. It is 5 times stronger than steel and at least twice as strong as any impact resistant material currently in use as protective gear. It has withstood the equivalent dropping of 4 diesel locomotives into an area the size of a fingernail. So you can see the material is so strong that even if you strike it with 4 locomotives, that is vehicles, it does not get it does not break. So possible applications of this new nanomaterial are ballistic protection, personal body armor, bulletproof vest, vehicle armor, shields, helmets, and protective enclosures. So you can see here that is military, in the military vests which are used by the soldiers, they are also used there. So next, how the mechanism takes place here, a nanomaterial used in bulletproof jackets or vests. So glass is the first coating, so this breaks, but when it breaks, the other that is coatings, you can see here, the first layer of glass, it shatters, but when the bullet hits it, however, the next layers are of polycarbonate. So the polycarbonate is more elastic, so it moves with the bullet hits, and which dissipates the energy of the bullet horizontally, and this takes the energy away from the bullet, slowing it down. If the enough energy is taken from the bullet, it will eventually stop it from passing through. So you can see here, these polycarbonate materials does not allow the bullet to penetrate into this, that is the bulletproof vests. Then they are also that is in military, nanomaterials are also used for making cockroach drones, which fly in swarms, hover like bees, crawl like spiders, and even sneak up on the suspected targets and execute them with lethal precision. So these were all the applications for nanomaterial that is in military. Now we go to the paints. So nanomaterials are also used in paints. Mostly titanium oxide is used in paints because it has 2 excellent properties, that is, it has a photocatalytic activity and UV protection. So combination of photocatalytic activity, so along with its hydrophilic property, results in paints, that is self-cleaning effect. So addition of silicon dioxide, that is nano silicon dioxide, to the paints can improve the macro and micro hardness, abrasion, scratch and weather resistance. So adding nano silicon dioxide to polymeric resin creates paints with excellent abrasion properties. Surface coated with nano silver containing paint provide excellent antimicrobial properties against bacteria and human pathogens. So nanotechnology is also used in fabrics. Here when a nano-sized components is added to the fabric, material performance is increased. Some clothes are made out of this. So making this clothes, when we add like silver nano materials to clothes, these clothes become water and stain repellent. Okay, so making spill and dirt resistant and also antimicrobial and bacterial fabrics. So by adding silver nanomaterials to the fabric, not only they become water repellent and stain repellent, but also antimicrobial and antibacterial are made out of this. So nanotechnology in electronics, electrodes made from nanowires enable flat panel displays to be flexible as well as thinner than current flat panel displays. Nanolithography is used for fabrication of chips, as I've told you earlier. These transistors are made of nanowires which are assembled on glass or thin films or flexible plastics. E-paper displays on sunglasses and map on car sheets. So this nanotechnology is also used in mobiles. You can see here, Morph, a nanotechnology concept device, will be a super hydrophobic, making it extremely dirt repellent. It will be able to discharge itself from available light sources using photovoltaic nanowire grass covering its surface. Nanoscale electronics also allow stretching. So you can see here the mobile is totally folded, you can see here. So stretching is present there. So mobiles can be bent, stretched and folded into any number of conceivable sizes. So nanotechnology also finds uses in computers. The silicon transistor in computers may be replaced by transistor based on CNT. The carbon nanotubes is a molecule in the form of hollow cylinder with diameter of around a nanometer, which consists of pure carbon. So nanorods is upcoming technologies in display techniques due to less consumption of electricity and less heat emission. Size of nanoprocessors are reduced to greater extent. Okay. So this is what is in. Now nanomaterials is also used in cosmetics because we have to use internally, they should be examined very much carefully. So these play a very important role in beauty and cosmetic products. Nano-sized particles have smaller properties than larger particles of the same substance. Smaller particles can easily penetrate the skin and introduce active ingredients into the skin's deeper layers. The use of nanotechnology in cosmetics is associated with risk concerning health and environmental issues. So it is still a insufficiently explored field. The potential associated risk and regulation that has been implemented to maximize that. So you can see here, this carbon 60, it is being is used. This is carbon 60 is a black carbon. It is a mostly iconic nanomaterial. It is approximately 1 nanometer in diameter with a truncated isohedron structure resembling a soccer ball. So this carbon 60, it is used in cosmetic industry as a black coloring pigment and is characterized by a particularly high color intensity and depth. It finds its uses in mascara, eyeliner, eyeshadows, eyebrow pencils, and nail polishes. So carbon black has been approved as a colorant since the beginning of European Union cosmetic legislation and is used worldwide today. It is applied in highly pure form and is subject to strict quality requirements. So next applications of this cosmetics, we found it is by using of micelles. Micelles are nano-sized molecules that arise in mixtures of amphiphilic substances, surfactant, and water. When the surfactant concentration reaches a certain level, that is critical micellar concentration, the surfactant molecule begin to rearrange themselves. This reaction creates small spherical micelles exhibiting both lipo and hydrophilic properties. So both, that is lipophilic as well as hydrophilic properties, are seen in micelles. So these micelles are used in facial cleansers or tonics. They gently remove dirt particles, makeup, excess sebum from the skin by enveloping the lipophilic materials to be removed. What's more, during cleaning process, nourishing ingredients can be applied and transferred into the skin. So this is what that is the cleansers. In cleansers, micelles are being used. So here you can see here the exam figure which is given here. This is the figure of a micelle. So many surfactant molecules come together and they form a micelle, and this is that is a surfactant molecule, amphiphilic. It is amphiphilic because it has hydrophilic as well as the lipophilic in the same, that is in the same, that is surfactant molecule. Now this is what we do in our lab. that is, we synthesize the nanomaterials, and for this we use the electrochemical reduction method. This is the experimental setup. So you can see here the sacrificial metal, means of whose nanomaterials we want to prepare, that is taken as anode, and platinum is taken as cathode, and we are using tetrabutyl ammonium bromide, that is as a surfactant, and we are using the solution that is acetonitrile and THF, that is 4:1. Then we are applying current density of about 12 milliamperes per centimeter square for about 2 hours. Now here an example it is given is of, that is copper. You can see the dark green colored colloidal solutions are being formed here, and this is a colloidal solution, and the settling of this colloidal solution, it requires at least 2 days. You can see here this in the figure, the positive one is the sacrificial anode, and the platinum is that is negative. So what happens is that this metal anode, it releases its ions. Like suppose we are using copper there, so it releases copper ions. These copper ions migrate towards the cathode. After migration, they get discharged. As soon as they get discharged at the cathode, they get capped by the capping agent, which is tetrabutyl ammonium bromide or tetraalkyl, any of you can take tetraalkyl ammonium bromide. Here we have taken butyl. So they are trapped by the tetraalkyl ammonium bromide, which is a surfactant, and they form a the solution becomes a colloidal, and it requires at least 2 days for settling. So after settling, it is washed 2 or 3 times with THF, and it is dried in vacuum desiccators and then used for the characterization purposes. So you can see here the characterization which we are using is UV IR. You can see here this is for this, whatever we are showing here, it is for zinc, which shows the absorbance at near about 277. Then zinc nanoparticles, you can see here because some impurity is there. You can see here OH is also found here, and NH is found, and at this zinc oxide nanomaterials particles, you can see the frequency is very much less. It is like 410 to 541. So a sharp peak which is observed here, which indicates that the nanomaterials have been found. Then we have the XRD pattern. So the size of these particles can be carried out, can be found out by using Debye-Scherrer equation, and also we can calculate their shape. You can see here hexagonal Woodside particles of zinc oxide nanomaterials have been found, and the size you can see of this is like near about 46.5, 37.3, 50.8, 53.9, and 31.5. So you can see this is what is the average crystallized site of zinc oxide nanomaterials. Then we have done the characterization of SEM and ADX. So you can see here the shape when we do scanning electron microscopy. We found here flower-like shapes. Some are spherical, and rod-like shapes are also being formed. And when we have done the ADX analysis, you can see here the graphs which show they are of only zinc and oxygen, and if you make the total of this, it comes to 100. So we say here that the ADX analysis shows that the nanoparticles synthesized by electrochemical reduction method, it is found to be highly pure in nature. Then this is a transmission electron microscopy, and the D part, that is the Z pattern. So from this, the size of the particles has been calculated, and here this in the Z pattern, you can see different peaks are there. They are in agreement with the XRD data, which indicates that crystallinity of our formed nanoparticles. So you can see here from this graph, the average size of nanomaterials, which is or zinc oxide nanomaterials, which have been formed, that is about 34.44 nanometers. Then we have used this zinc oxide nanomaterials for the sensing to study the sensing properties. So why produce this nanosensors? Because they are smaller, require less power to run, greater sensitivity, and better specificity. You can see here this sensor, there are of many types: colorimetric sensor for quantum dots, magnetic sensors, photoelectrochemical sensors for zinc, then gold, chemical sensors, electrochemical sensor for graphene sheets, and so on. So what we have done is that we have used here the metrum of PG-stat here, which from on this instrument we can study cyclic voltammetry, difference pulse voltammetry, that is DPV, square wave voltammetry measurements. So in this that is PG-stat, this compartment consists of 3 electrode system, that is AgCl, which is a reference electrode, then a platinum electrode and a modified platinum glassy carbon electrode as a working electrode. So here we are carrying out the electrochemical studies of dopamine in 0.1 m molar PDS at a room temperature. So the CV, DPV and SWV were carried out at various concentration of dopamine in the range of 50 to 50 micrometers, 50 micromolar solution to 350 micromolar solution at 100 millivolt per second. So voltammetric studies have been done. The potential scan was taken from minus 0.6 to 1.0 volts at different scan rates in the range of 25 to 150. So here, this is what we have done here. And we have studied the dopamine. Then we have the sensing of dopamine. Now, why we have done the sensing of dopamine? Because dopamine is a monoamino neurotransmitter that upon binding to a dopamine receptor, that is G protein coupled, releases a variety of downstream signals. Dopamine plays a significant role in cardiovascular, renal, hormonal, and central nervous system. It is thought to control processes as diverse as movement to drug addiction. Dopamine dendrites extend to various regions of the brain, controlling different functions through the stimulation of a beta adrenergic and dopaminic energic receptors, that is D1 and D2. What are the functions of dopamine in a body? The function depends on type of receptor involved in pleasure. So this dopamine is a pleasure hormone involved in motor control of muscles in the body and assists normal brain functions, induces emotions. So first of all, we have prepared the zinc oxide nano materials modified electrode. So this electrode was prepared by adding zinc oxide nanomaterials to a 0.1% Nepean solution, that is 2 ml, and sonicated about 20 minutes with ultrasonicator to get a homogenized suspension. Then to prepare this glassy carbon platinum modified electrode with zinc nanomaterial, alcoholic solution of 0.1% Nepean, dispersion of zinc oxide nanoparticles was prepared, and the suspension was cast on the surface of pre-treated platinum gold glassy carbon electrode. So this solution was allowed to evaporate at room temperature for 2 to 3 hours. And then you can immobilize zinc oxide nanomaterials on this platinum glassy carbon electrode was done. So this has been used for the study then. So you can see here the electrochemical detection of dopamine has been done by using zinc oxide nanomaterials and glassy carbon electrodes. These are the different, the first A, it gives you the glassy carbon, that is the red line. It is a bare without using, bare means without using zinc oxide nanomaterials, and the blackish or bluish one, that is glassy carbon electrode modified by zinc oxide nanomaterials. So this is, you can see here, it is the study is being given here. And here, as in B, you can see here at different scan rates, the same experiment is being carried out, and the scan rate varies from 25 to 150 millivolts in 0.1 molar potassium ferrinitrate solution, in 0.1 molar potassium nitrate solution. And you can see here from these to A and B, we have plotted the graph, that is a scan rate, that is C graph is for the A1, and the for D, it is obtained from the B. And in this way, we have done the electrochemical detection study of dopamine. So here, you can see here, these are again the different scan rates, that electrochemical study, CV, that is cyclic voltammetric studies. And the sensitivity by using of this, it has been found to be 0.477 microamperes per micromolar centimeter square and 0.636 microamperes per micromolar centimeter square. So this is what is being found for zinc oxide nanomaterials. Now similarly, we have done the square wave voltammetry, and this is the differential pulse voltammetric studies. Then here you can see here the regression equation yielded the correlation, that is R2 is equal to 0.957, and the sensitivity was found to be 1.16 microampere per micromolar centimeter square. So here this is you can see here the first 4, 5, they are from the other work, that's our reference work, and you can see the last 3 is our work. So we have used zinc oxide nanoparticles, that is with glassy carbon electrode. Then we have also used aluminum oxide nanomaterials and glassy carbon electrodes, and then we have combined, that is zinc oxide and aluminum oxide nanomaterials with that is the zinc glassy carbon electrodes, and you can find that we have got this sensitivity which was found to be, that is in a that is about 10 to the power of -2 to 3 in this range, which found out that is our work is much more sensitive as compared to the other work which is given in the first 5, that is table. So then not only this, we have done our electrochemical studies. We have done I have shown you regarding the dopamine studies, but we have also done our electrochemical studies for detection of glucose, for detection of ascorbic acid, uric acid, nitrate, and hydrogen peroxide, and we have used different nanomaterials, that is metal nanomaterials. And you can see here the last one, we have also used polypyrrole platinum oxide, then polypyrrole palladium oxide, and polypyrrole tungsten oxide. So this also hydrogen peroxide study, we found it to be very much sensitive. So then we also have done the catalytic study also, that is synthesis of benzylidyl malonitrile derivatives via 2-component reaction of malonitrile and aldehydes. So you can see here malonitrile and here aromatic aldehydes has been used, and copper oxide nanomaterials have been used in 5 molar ethanol, and was this study has been done by using ultrasonic method at room temperature. So the reaction was time required was very less. We got you can see here the time required, you can see it is by using our catalytic is hard. Here it is seen here. This is our earlier, this is the solvent free medium, ethanol oxide, water, and methanol. We have all used all these 3 solvents, and we found that all these 3. But using methanol oxide, we found that the time was also less and the yield was also much more higher. And the catalyst also was done. So 50 milligram catalyst gave us 94% of yield, and we have done all the characterizations by using FTIR of that is our product to benzylidene malonitrile, that is we have done their IR, then NMR and C13 also, and this is the derivatives which you have got for this benzylidene malonitrile. So this is again the characterization of this our product, that is IR, C13 and NMR. And we have done all, not only this, we have done novel jet condensation, then Debus Radis imidazole synthesis, Claisen-Schmidt condensation, Bignelli reaction, Hans condensation, Erlenmeyer-Polk azolactone synthesis, multi-component cyclization reaction, 3-component condensation reaction, multi-component reaction, and condensation reaction by using again a different nanoparticles. You can see we have used here copper, aluminium, then titanium, nickel, zinc, and so on. So we can say that nanomaterials will in future be used to clean industrial water pollutants in groundwater. Future of nanotechnology could include the use of nanorobotics. These nanorobotics have the potential to take on human tasks as well as tasks that human could never complete. The rebuilding of depleted ozone layer could be potentially be able to be performed. There would be an entire nanosurgical field to help cure everything from natural aging to diabetes to bone spurs. There would almost nothing that couldn't be repaired eventually with the introduction of nanosurgery. Thank you very much.
So thank you, Dr. Respected Anjali Rajbhoj Madam. Very wonderful and informative lecture. Now this session is open for a discussion. If
yes, sir. I am having one question, sir.
Yes, sir. Yes, please.
Your presentation is nice. Nicely you have presented the nanoparticles in such a detailed way. That
Thank
is
you.
a good thing. One thing I want to ask, there is the problem maybe occur because of its size, the nano size. You don't think that these nanoparticles will going to disturb the immune system of the organisms?
Yes, sir. Yes, sir. They are toxic when they come in contact with our skin. So my students, when they do this, that is synthesis of nanomaterials, I strictly instruct them to use the gloves, because when they prepare this nanoparticle and if they come in contact with the skin, they can easily penetrate into the skin. So that we have to take the cautions that they should not come in contact with our that is human beings. And not only this, but when we find applications, I think the people who are doing work on nanomaterial must surely be taking these precautions for preparation, not in various applications like medicine, as I've told you, then the military and so on.
It means it is going to disturb the immune system.
No,
If you will apply continuously to the body.
no, sir. So everything has two sides, sir. When you don't take precautions, it can be harmful also. So this is applicable to everything, sir. Excess, when you do something in excess, that is also harmful for us. So same thing applies with here the nanomaterials also. So we have to whatever we have to do, we have to do it cautiously. This is what I say at the end.
Okay. Thank you.
Yes. Thank you.
Okay, any more questions from participants?
Sir, I have a question regarding nanoplastics.
Yes, ma'am.
So they say nanoplastics are leaching into the environment and causing so much trouble. So what do you have to say about this?
How they are reaching in the environment, you say?
No. So why is that there is no technology to take these things out of the environment so that leaching of nanoplastics can be avoided? What can be done?
Nanoplastics, you are saying?
Yes, ma'am.
So plastic, that is totally a different field, ma'am. What we can do at the most is use of this nanomaterials for degradation purposes of this plastic. That can be done by using of this nanomaterials.
Yes. I wanted this answer only. What can be done to clean those
Yeah.
nanoplastics from the environment?
Yes, that we can do. And I have
Thank you,
shown
thank you.
wastewater treatment also, this can be done.
Yes, ma'am. Thank you, ma'am.
Thank you, ma'am.
Hello, madam.
Yes, sir.
How to do the green synthesis of nanomaterial?
So we can do, actually I haven't shown it in my slide because of the time constraint, but many of our students of MSc, they use the plant extracts, and they using this plant extract and like any that is copper chloride or nitrate can be, solution can be used, and when you put that extract into that, that is our metal salt. Yes, so we can make nanomaterials or nanoparticles from that. That is the green method, I suppose. And also in some cases microorganisms also help for preparation of nanomaterials.
Ma'am, my question is how nanomaterial is useful in nanorobotics?
Sorry, sir.
How nanomaterials useful in robotics?
So technologically, I cannot give you that how they are used, but I've shown you one example regarding how the bullet it cannot penetrate into the jackets or vests of a soldier, because the first layer, though it is of we can say it may be of steel or something. First layer they can penetrate, but the second layer, because it is of polycarbonate, which is a very robust materials, which is also used in aeroplanes, windows of the aeroplanes. So it is a very robust material, and that is the bullet, it cannot penetrate into the military vest. So this is how actually it finds uses in this military That is, we can say. Yes.
Okay, so I think
satisfied?
you are
Yeah.
satisfied with the answer.
Are you satisfied with the answer? Yes, that's what I was thinking.
Okay, so I think it's over. So thank you once again, madam, for a very wonderful and informative lecture.
Madam,
Yeah.
Yes,
which type of nanomaterials using for cancer treatment, madam?
Actually, cobalt, earlier cobalt was used for treatment of cancer in the form of radiations. Platinum also finds its uses in this treatment of cancer. This platinum.
Hello guys.
Any more questions from participants? Okay, so then we conclude this session. So thank you, madam, for this nice presentation.
Thank you,
So
sir.
now, finally, I would like to invite Professor K.P. Jadhav, sir, Assistant Professor in Chemistry, Jagat College, Goregaon, to propose the vote of thanks. Please, sir. Professor Jadhav, sir.
Hello, sir. I am audible?
Yes, 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 sir. Yes, sir, yes. Stop share.
Thank you, Dr. V. Rangale, sir. Now we are moving towards the last part of this webinar, that is votes of thanks. Good evening, Honorable Chief Guest, respected invited speaker, respected principal, teachers, and my dear participants. I wish to express my heartfelt thanks to our respected President, Honorable Sri Jagatramji Rangale, sir, President of Bahujan Hitai Jagat Shikshan Sanstha, Gondia. It is your vision and leadership that has brought everything possible on this campus. Thank you, sir. I would like to thank Honorable Professor T.V. Prabhu, sir, President of Association of Chemistry Teacher. Thanks a lot, sir. My very special thanks to the Chief Honorable Professor Tejas Paresh, sir, ex-President of Association of Chemistry Teacher, who gave an inspirational, valuable speech. Thanks a lot, sir. I would like to thank you, guest speaker Sonia Carabino, ma'am, Nova University of Lisbon, Portugal, and Professor Gladys Completo, Institute of Chemistry, University of Philippines, Los Banos, Laguna, Philippines, for enlightening us with their knowledge. Today's webinar was full of knowledge and great things. Thank you so much, ma'am. I would like to thank you, guest speaker, Dr. Anjali Rajboj, Madam, Senior Professor, Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Sambhaji Nagar, for their insightful and fruitful speech. Thanks a lot, Madam. I express my sincere thanks to our respected Dr. N.Y. Lanjesar, Principal of Jagat Art, Commerce and Indiraben Hariyarbai Patel Science College, Goregaon, for his constant support, motivation and guidance. Thanks a lot, sir. A heartfelt thanks to our Vice Principal, Dr. S.H. Bhairam, sir, for your support and leadership. Thank you, sir. I would like to thank you, a great personality, our Dr. Vasudev Gurule, sir, convener of Global Women Breakfast 2025, Vice President, West Zone of Association of Chemistry Teacher, for his valuable guidance and help us in all aspects of this program. Thanks a lot, sir. I would like to thank you, HOD of Chemistry Department, Dr. S.T. Nandeshwar, sir, Dr. G.K. Bhagat, sir, Science Faculty in charge, and sincerely thanks to Dr. S.S. Rangdale, sir, organizer of GWD 2025 webinar, and IQSC coordinator, Jagat Arts, Commerce and Indiraben Hariyarbai Patel, Science College, Goregaon, for guidance and help us. Thanks a lot, sir. Especially thanks a lot to Dr. V.U. Rangdale, sir, co-convener of GWD 2025 and IQSC member of Jagat College, Goregaon,
he is working so hard for making today successful webinar. Thanks a lot, sir. Finally, a big thanks to our participants, teaching staff, non-teaching staff, and technical staff for joining us on this special day. Thank you for everyone. Thanks again to IUPAC WG 2025 organizer team for their efforts. Thanks a lot, everyone.
Thank you, Jadhav sir. Now, by the permission of convener, Dr. W.B. Gurnul sir, I request all the participants to please switch on their camera, turn on their camera to have a group photo. Yeah, please.
Please turn on your video camera. Video camera.
Okay, thank you to all. Okay, thank you. Thank you, madam.
Thank you, sir.
Thank you.
Thank you, Professor
Okay,
Sonia,
thank you to
madam.
all of
Thank
you.
you,
Thank
Anjali,
you.
madam, for
Yes,
nice
thank you.
presentation and
Yes,
accepting our invitation.
thank you very much, sir.
And thank you,
giving me
Pankaj
an
sir.
Thank you to all of you.
opportunity.
Yeah, one thing I would like to share you that the feedback link will be provided on email, so that by filling that you can get your certificate. So it may take 2-3 days because we have huge number of participants. So it may take some time. Okay, so thank you once again.
Shall we leave, sir?
Yeah, yeah.
Yeah, yes, ma'am.
Thank you again, all of you, for giving me.
Yeah, thank you, madam.
Thank you. Bye bye.
Yes. Okay, bye.
Bye.
Bye bye.
Thank you, sir.
Yes, Anjali sir, bye.
Bye,
Yes.
sir. Bye.
Thank you, Guru sir.
Thank you, Dr. Pankaj sir.
Thank you,
Pankaj
sir.
for joining. Yeah, yeah.
It
We are
was very
meeting only online.
informative.
Yeah, yeah.
Yes.
Thank you, Gurule sir.
Yes, sir. Yes, sir. Thank you.
Hello, Gurule sir. Thank you.
Thank you, Lanji sir. And congratulations to you.
So,
अगं मला त्रास होते मी नाही बोलू शकत ह्याच्यानं कर डोळ्याला त्रास होते बंद कर असं व्हॉइस कॉल कर
What is your age?
Stop
I'm
the sharing now.
51. फिर आप तो छोटे लगते हो।
Anjali sir.
चलो मैं छोटे कहाँ मैं डॉक्टर साहब वेट बढ़ गया इतना।
Yes, sir.
वो डायबिटीज की वजह से इंसुलिन लगती है। अरे इंसुलिन से क्या वेट बढ़ता है मैं और क्या?
अच्छा वेट कम करो ना कख नहीं पता मुझे डायबिटीज है नहीं फिर अच्छा वेट कम करो अपना उससे भी बड़ी प्रॉब्लम्स होती है एलर्जी वगैरह की हाँ वेट कम करो कोशिश करो चलने की करो कहाँ रहते हो माँ छन्नी में उधर तो बड़े पार्क हैं गए शूज लगाए चक्कर लगाए थोड़े
हेलो
हाँ,
हेलो